Hello, everyone. Good morning. Just want to check if I'm audible from your side.
Good morning. What is it? My side?
Good. Okay, let's start the webinar for today. Once again, this is Michelle, your facilitator for this training, and I would like to thank you all for taking the time to join us today as we talk about Lean Six Sigma Yellow Belt. We do hope that everyone will actively participate and sit during the entire session, as we've got an interesting announcement for you at the end of the training. So stay tuned to learn more about it. During the session, please feel free also to drop your questions by making use of the chat box here so that the service team or the trainer can respond accordingly to your queries. However, please make sure to keep yourselves on mute to avoid any distraction during the session. Moving forward, I'd like to present to you a short video clip introducing International Management Consultancy.
Quality, innovation, respect, and integrity. Take steps to invest in your career. International Management Consultancy is the leading global marketplace for learning and instruction, helping professionals across the industry to develop skills and expertise to get recognition and growth in the corporate world. We are one of the leading training providers and gradually spreading our training facility amongst candidates based at different geographies, such as Canada, United States of America, United Arab Emirates, Saudi, Kuwait, Qatar, Oman, Lebanon, Pakistan, Bangladesh, Vietnam, Philippines, India, and many other countries across the globe. IMC is accredited by the highest industry standards. We put in the efforts and we work to prove our commitment to offering our clients only the best and of superior quality. With a uniquely immersive curriculum that combines live instruction from the leading experts, peer-to-peer collaboration, on-demand lessons, unlimited online trainings, and 24/7 learning support. IMC helps over thousands of professionals learn their skills needed to advance their careers and reach their full potential. In line with our commitment to excellence, IMC offers a number of training courses preparing professionals for certifications and exams given by the international associations in areas like management, finance and accounting, human resources, sales and marketing, quality administration, and as well as project management. By fully attending these courses and successfully completing the requirements of the certifying body, participants will receive a special certificate which recognizes their dedication and commitment and in many cases help them earn valuable continuing education credit. IMC Consultants has been working together with their clients from various industries in aligning their people and processes to compete through high speed, excellent quality, and low cost. We strongly believe that the key to our success is our total commitment in delivering value to our clients based on integrity, honesty, and openness. If you are uncertain about which roles or skills are best for you, hurry! Come visit our website or talk to our expert education consultants today. Take a step, invest in your future, empower your knowledge, and be one of our success stories. International Management Consultancy, excellence is what we deliver.
Thank you everyone for watching the video, and I hope you're able to get an idea and know about IMC and their services. So moving forward, before I introduce our trainer, some of you might be thinking of what you will learn for today's session. Hence, I'd like to give a few points of what are the key takeaways that you will get from this training. So you will learn how to define and understand quality concepts and the evolution of Lean Six Sigma. You will learn how to discuss Six Sigma and benefits to sustain business improvement, explain the role of Six Sigma in customer service and continual improvement, apply and implement the define, measure, analyze, improve, and control problem-solving methodology, examine the statistical background supporting Six Sigma projects, and also compare between the various tools usually used in a Six Sigma project and explain how to deploy Six Sigma and assess organization readiness to launch a successful Six Sigma project. So without further ado, let me introduce to you all our Lean Six Sigma expert for today. He's a Delhi University graduate with over 20 years of diversified experience in operations, project management, operational excellence, audit, training, quality, and compliance with over 150 plus customized trainings conducted for corporates on Lean Six Sigma. He is also an approved trainer of Activet, or the Abu Dhabi Center for Technical and Vocational Education and Training. He catered major institutions such as Qatar University, Indian Institute of Technology, and Indian Institute of Management, and many more. Please all welcome Mr. Shashi Prakash. Good morning, Mr. Shashi.
Good morning, Michelle. I hope I'm loud and clear.
Yes, sir, you're audible.
Perfect. All right. Thanks, Michelle. I'll take it up from here. So a very good morning, good afternoon, and good evening to people, because I've got, I think we have got people from every part of the world. So thanks everyone for joining in for this Yellow Belt training program. And in the meantime, would request you all to please confirm in the chat if I'm audible to you with a quick yes. Thank you. Thanks a lot. So before we move ahead, let me just quickly go back, just talk about certain things that I'm sure while you're going through that presentation for IMC, it's very important to understand some important elements that were picked up and were explained in the video, which is definitely important for each and every one of us, at least if you have plans to get into Lean Six Sigma. It really matters a lot. Where are you getting the certification from? And that's where I would like to bring your notice on those elements which were covered in that quick, brief introduction. IMC as a training provider, they are accredited with, when we talk about Council for Six Sigma certification, which is based out of USA. They are accredited with International Quality Federation, which is again based out of USA. They have accredited with the CPD UK, which is CPD accreditations are taken by lots of universities in Europe. So that's where they have got accreditation from. And more importantly, IASSC, which is again UK based. That's something every institution which is in training provider, as a training provider, wants to have the IASSC accreditation. So with that sort of volume, when you speak about the credibility that it brings on your certificate, when we, as a consultant, as a Lean Six Sigma Master Black Belt, when I do my projects and I hire for my projects, or when I hire for my clients, when we generally hear from various recruiters, IMC's certificates have good value, good reputation in the market, and the best of all, it's lifetime. So you don't have to get into the botheration of getting it renewed and all that stuff. So that's where certain things you got to keep in mind. Where are you getting the certification from? So from on those grounds, well, you would never ever have any concerns because of the weightage that brings to your certification, all those accreditations and standards that IMC has been able to maintain all this while. So that's number one. Number two, we definitely want to talk about the training methodology. In order to maintain those standards and maintain those accreditations continually, one has to ensure that we are training people on what's trending in the market, what's needed by the corporates globally. So we have been putting a lot of work in the content development to keep evaluating the content to see what's trending in the market, how the market, because this market is very dynamic. It's changing at a very, very fast pace. And hence, it becomes imperative for us to continually audit and ensure our content, the training delivery is up to the mark and at the level of what's been practiced in the world. So if I talk about the training methodology, this is what our students have been able to get, which I would not like to name any institutions, but yes, for now, have a look at this. This is what you do in a real world Six Sigma project. These are simulation projects, which are participants have gone ahead and done. This is the level of understanding we end up delivering. So the people of how you got to be doing a project in real world, that's get covered. That level of understanding. We're not talking about theory. Well, technically Six Sigma's job is a practitioner's job. You will be solving a business problem for the stakeholders, whichever industry, whichever department, domain you may come from, but there are business challenges. And Six Sigma happens to be one unique tool which will help you solve problems in any department, any industry. It has no boundaries. Well, I personally come from a service industry background, but I have been catering my services to almost every possible industry now. Well, it talk about oil and natural gas, you talk about constructions, you talk about pharmaceuticals industries, you talk about general healthcare, hospitality, publication houses, IT, data centers, practically whatnot. And this is what Six Sigma can do to you. You have no limitations thereon, should you get the concept right. Well, there's your chances of doing well in your career increases by multiple folds. And that's why Six Sigma people are very, very expensive resources. If you compare with the general audience with a similar kind of skill set and similar kind of educational qualification and experience, Six Sigma professionals are very expensive. So practically on that note, I would like to kind of make sure that there's a big gap. Well, as I said, when I hire for my projects or when I hire for my client and a lot of other such recruiters and stakeholders, when we interact with them, the biggest disappointment which most of the recruiters or stakeholders bring about is that people have got theoretical knowledge. Well, you've given an exam, you write an exam, you pass the exam, but I don't know how to do a project. Well, I may have theoretical knowledge, but the transition of theory to the practical is the biggest challenge. So people come across, yes, they have a certificate which says that you've taken a Six Sigma green belt or Six Sigma black belt training and you've passed that exam, but you don't know how to use it, how to apply it. I might know 20 different tools, but when to use what is the missing link. And that's where the transition is required. And we ensure that you learn the way it needs to be learned, which is more of a practical approach, hands-on approach, rather than teaching you theory. Well, it's unfair if I teach you theory and then expect you to understand how practical works. That's what we end up delivering. So what is needed, it has to be taught in the right way. So this is what you end up learning, a practical way of doing the project. This is how a real world project would look like. So this is the level of competency we end up delivering by the end of the project, the entire training program. By the way, yes, you get an extra certificate. This is where when we talk about completing a certificate, yes, you definitely pass an exam, you get your Six Sigma green belt or black belt certification done. But if you complete a project, which we provide you data for, well, pretty much you get an extra certificate which says that, yes, you have completed a Six Sigma simulation project under the guidance of a master black belt. So practically, this is what is needed for you to compete in the market and to be one of the best. Like if you want to explore different industries, change your industry, change your departments, well, that's the key. But you got to have this level of understanding, which some of our, when we talk about the students who have already gone through a program, this was more from an IT world. Well, that's from manufacturing, and there are lots of ones. This is from manufacturing sector. Well, depending on whatever it is, it doesn't matter. As I said, I've come from a service industry background, and I deliver projects in every possible industry. So there is no foundation. If you understand how to work on a project, this is how typically you should be able to use your knowledge, the skills that you learn in the entire course. So practically, this is a quick glimpse of the level of understanding which needs to be developed. And unfortunately, this is not how it's taught globally. Well, I train for a lot of institutions. Well, whenever I talk about universities, technically there are a lot of other institutions also, but the gap is, as I said, it's important to understand the right way, which is more about experiential way, the practical way of doing things. So we talk about this. Second, this is more from a perspective of ensuring that you learn it the right way. Number two, about ensuring that, well, people, when we go through a Lean Six Sigma training to understand about the different project management tools, quality management tools, and the statistics, which definitely is a big part of Six Sigma. Globally, when we apply for jobs, the corporates are looking for people who have understanding of how to use Minitab. Minitab is the most advanced statistical software, which is demanded by most of the corporates. Well, every month, at least I have one corporate batch going on where I'm training people who are Six Sigma Green Belt, Six Sigma Black Belt from a corporate level. They have got the training, they've got the certification, but they don't know what is Minitab, or probably have barely used Minitab. I've been doing extensive training on Minitab only for corporates. These are things which our participants do not have to worry about, because when we learn, we do it parallelly. Nowadays, corporates want Six Sigma people, but with Minitab understanding, because that's what they use. And this is how extensive it is. So while you learn it the right way. While you were showing you the projects, the sample project, yes, people have, participants have used the Minitab, and this is how it looks like. It is the most advanced software when it comes to Six Sigma, and practically globally, everyone uses Minitab in Six Sigma world. It's what we make you learn, practice in and out. So while you learn it the right way, how you will be doing the work in real world. Well, otherwise, nowadays, corporates do not have time and bandwidth to wait and train you, because that's an expensive training. What we end up doing specifically for Minitab at corporate level, globally, when corporates are getting into cost cutting, they're trying to reduce the cost. They want ready material. Well, people should have practical knowledge. People should have Minitab knowledge. All that is demanded. So if you just have one piece of certification, well, if you don't have the practical way of understanding, well, that's of no use. It's just a mere certification which you add on your profile. Well, if you have it, if you don't have understanding of Minitab, well, somebody will be better off who knows that Minitab piece, because the corporate understands I don't have to invest in this person. These are expensive trainings. So you learn everything while you learn the Six Sigma. So on that note, I just wanted to make sure that at least you have a fair bit of understanding about entire scheme of things. When we go through Lean Six Sigma way, it's more about the tailor-made customized training, keeping in mind what's trending in the market, not what was taught probably 10 years ago. Things were very different. Now things are different. Like, so you got to leverage the technology. And that's what, if we talk about Lean Six Sigma, well, there's no end to industries where it's being used. That's a very, very compiled, not all of it, but a compiled list of all the case studies in different industries. The Six Sigma, we may not have experienced in our organization, but people are using it in every possible industry. You have, these are different areas, and this is not the all of the departments and industry that we talk about. Six Sigma is used everywhere. Well, people have been using it globally, and that's why it become a primary choice of most of the stakeholders globally. And there are tons of such case studies. I'm trying to keep on adding more and more stuff as we keep getting it. But bottom line, there's no industry in the world where you will say, well, Six Sigma is not applied. Every industry, at least I've gone through like lots of diversified sectors, and people are using Six Sigma, and industries are willing to invest in Six Sigma projects. So the need of Six Sigma professionals have gone much higher post-pandemic, because this entire pandemic has got corporate into time cost crunching mode, and Six Sigma does wonder when it comes to cost saving. So on that note, I hope everyone is out here is for that specific purpose. And these are the things which we actually look for. When real world project, you're trying to invest your time. I truly respect that. And I really thank each and every one of you to take out your time. But trust this time period that we're going to spend now, I would want you to please ask questions. If you have questions, please use the chat option. I'll try to give you the gist of what I have learned in the Six Sigma world by doing these trainings and by doing these projects. At least you should get the real essence what Lean Six Sigma can do to you. So if you have questions, please do not hesitate in asking. It's very important. We do not keep it like one-way monologue, because it's going to be very, very boring. You would not be able to make sense. So the options are open. Please do share your question. I'll explain topics. I'll come back to you. But it's important for you to engage. That's how you can make the best out of this session. So I hope everyone is with me on this one. Is everyone on the same page? We have a common understanding about this. Okay,
Yes.
perfect.
So,
Great. There would be certain questions which
Yes.
might be coming our way about the recordings, about the certificate and all those things, the training material, everything. By the end of the training part, we will definitely be answering those questions about the training, about the certification, about the training material. Everything will be covered by Michelle. Again, she started the entire session, so she will take it over from there and she'll address all those questions. So on that note, let's get started. First thing first, help me understand, is lean and Six Sigma two different words? Have you heard about it? Is it two different words or one word? Is lean and Six Sigma two different words or one word? Just one word. Two or one? Mark says one. Mr. Bakpoy says two. Perfect. It is actually Lean Six Sigma is two different words. It's not just one word. The two different methodologies completely. And they have been merged together now. So nowadays we don't talk about only lean. We don't talk about only Six Sigma. We talk about Lean Six Sigma. But they are absolutely two different methods of process improvement. Some companies might just want to work lean way. Some companies might want to work Six Sigma way, but that's gone. Nowadays, company will apply Lean Six Sigma together. So on that note, let's then get started with what is the meaning of lean here. Anyone would like to pitch in? What do you understand about lean? Your understanding of lean? What do you mean by lean? Waste. Okay, perfect. That's correct. How about anyone else? Waste reduction, cutting down waste. You could write about that. Lean is waste reduction. Thank you. That's correct. Lean is waste reduction. Well, then pretty much we are on the same page. You are 100% right about waste reduction. Lean is absolutely about waste reduction. So, but I would like to kind of rephrase the same definition, the answers you've given from a perspective when you appear for a job interview, the recruiter would like to ask you certain questions. And when although your answers may be correct and you might have given the technically correct answer, the answers may still sound incomplete to the recruiters. Why? They have not heard every possible word which should be included in the definition. So even though you answered it correctly, it will still be marked down as an incomplete answer. So we'll try to kind of rephrase this, but it's same going to talk about waste reduction. We're talking about waste reduction. So when we talk about lean as a definition, it's identification and elimination of waste, as you said, from the process to increase efficiency without compromising on the quality of product or service. Let's simplify this and understand what do you mean by this entire statement here. Bottom line, first it says, if you have to implement lean, you have to first identify. The first step is identification of waste from the process. When you identify, you go about eliminating it. When you eliminate the waste, your process efficiency gets better. While you implement this, well, you do not want to compromise on the product quality or service quality. Let's simplify, as I said. Let's assume there is a process, either it's a manufacturing process or a service industry. You're delivering a service or you're manufacturing a product. It doesn't matter. Every industry has process steps. Say there's a department A. There's some bit of activity is done in department A. The outcome of A goes to B. So the work then is done in the department B. They work on that step. Output of B goes to C. Then some work is done in C department. Then there is a D, then there is E, and then hypothetically, that's where my process steps gets over. So at the end of F step, my product is delivered or my service is delivered. Say hypothetically, it takes me 15 days time to complete this entire process of manufacturing a product or delivering a service at the end of 15 days. With the knowledge of lean tools and techniques, what we try to do is we identify, is this a waste? Well, we haven't discussed about how to identify a waste, but say hypothetically, we just started. So more bottom line, we'll try to figure out with the knowledge of lean tools, can you call the activities done in step A as a waste? Well, we'll use our knowledge of lean tools and identify them. Well, suppose we find out, well, there are activities in the step B which can be quantified as a waste as per lean definition. Yes, that's a waste. So with the knowledge of lean tools, we try to identify which all activities in your process can be qualified as a waste. Hypothetically, this is what we figured out, that step B has certain waste and step E has certain waste activities, which qualifies to be called as like waste as per lean. What do you do next? You've identified, you eliminate the waste. Now your process steps looks short. That's lean. In a simple layman version, a fat process has turned into a lean process. Now this takes me just 10 days. Well, isn't your customer happy? Yes. Customer is getting the product sooner. Customer is happier. Aren't you happy? Yes, you've saved a lot of time, effort, resource, everything. What you're wasting in step number B and step number E, now you're no longer doing that. So you optimize the process here. By optimize the process efficiency in terms of cost, time, efforts, resources, raw material, whatever you're applying in that step number B and E, now you're no longer doing it. You have saved money, you've become more profitable, you're delivering the product or service faster, which is you happy and your customers are happy. It's a win-win situation for both of us. But having said that, we cannot compromise on the quality of product or service. Well, whatever benefits customer was enjoying at the end of 15 days, that cannot be compromised at the end of 10 days. So there should not be a change in the product quality or service. That's when it will be a violation of lean. So we cannot implement lean at the cost of the product quality or service quality. That's what we do with lean. Lean is all about, when we talk about lean is all about speed of the process. Simply says, can you deliver the product or service faster? Lean is all about time. It's all about time. You want to reduce the time of the process. When you reduce the time, you would be able to save a lot of extra work here, because you would be able to deliver more output in the remaining time. So yes, you want to make it faster. How do I make it faster? By eliminating the waste. So that's what, when you want to make your process faster, how you do it? By implementing lean. This is what is all about lean. Technically, there are lots of steps. We will be able to, we'll discuss about it, but simple way, in simplest possible way. There's no other better definition of lean. Lean is all about time. You want to reduce the time it takes for you to complete a process. And how do you do it? By removing the unwanted steps in the process. And there are tons of them. We'll talk about it. We'll talk about how do you identify which waste, and trust, I can't teach you lean. Why? Because each and every one of you has been practicing lean. You know it. It's not a new concept that I'll be talking about. Lean is very, very commonsensical. Lean is something which we all have used and we all are using every day, most likely. But we may not have been doing it with a purpose. We may not have been doing it religiously. We might be doing it ad hoc basis. We may not have been quantifying it. So we never know how much is the benefit. With this entire Lean Six Sigma, now you start understanding there are a lot of activities which I do. It's lean based. I have been doing it. It's nothing new to us. And trust, when you implement, when you start doing it with a purpose in a structured way, you will be able to quantify the benefits in front of the management. Well, that's what is lean. Lean is very simple, and I will make sure that by in a moment that you all will be convinced with the fact that it's not new. We all know lean. But on the contrary, I would not say the same things about Six Sigma. But lean is very, very commonsensical. Everyone knows lean. On that note, let's have a quick short video and let's understand, do we know lean or not? A very quick short video, but will help us establish that fact. Remember, in lean, the entire purpose, let me just stop this video and I have to reshare with the audio so that you can have a look at it. Let me share this again with the audio. Now, remember, the entire purpose of lean is about delivering the product or service faster to the customer. That's the end objective. Have a look at this. I hope the audio volume is it's okay. Let me just go back. Is it audible to everyone while I was playing this one? Would request you please confirm. Perfect. So now, okay, let me play this audio once again, Melissa, for everyone. Is it audible? Manish, is it audible? Okay, perfect. Now let me play this again. Please watch out the video. As I said, every one of you know lean. Let's go and get going with this one. Let's get start this one. So here we go. We got to deliver a toast to the customer, some sort of any process, it doesn't matter. This is what you got to do. Watch out every single process step. You got to quantify the time it takes. Remember, lean is all about time. So you got to quantify every single activity that you do in your process. Which industries, it doesn't matter. Every process, every industry has process steps. And these are the process steps we're talking about. Every single activity. You got to quantify the time. Every single step.
The toaster on the right tends to burn the toast.
Remember, my end objective is to deliver and serve the customer faster and sooner. You got to understand the concept. It doesn't matter which industry, but we're tracking every single activity. Which industry you can relate with. But bottom line, every industry has process steps. We just got to quantify the time. You might have to go into changing the procedures that we follow, the steps we follow, unwanted steps. Everything has to be taken into account, but you have to know how bad is the process. So you're quantifying how bad is the process right now. Every single process step has been counted. Every single movement is an activity and it's taking some time. Remember, time. This is also taking extra time.
I know you're all this.
Hey Steve, did you want that toast plain?
No.
Too bad. She's trying to clarify requirement now.
Hey, about the
I got it.
about the
I got it.
really about the butter.
No, I got it.
Rach, no, really about the butter.
Oh, goodness.
Okay, here you go.
Rach, one piece would have been plenty. I really wanted jelly on it.
All right, so I guess we are clear about it. What is lean? Do you really need to understand about how to fix this process? Were there steps which could have been done better? I would like to understand from you with the lean perspective. We have not talked about anything, what you say, with identification of waste and elimination. We have not got into any technicalities, but do you already know what could have been done better to speed up the process? Any ideas that you have here? What could have been done better? Yes, use the fridge next to the roaster. What else we could have done? What else? Gather information. Yes, absolutely. Getting the customer requirement was the first thing, and she had no idea what she was doing. Everything was there was no planning at all. First of all, should have listened to the customer, and the way the things were organized, the way she was doing the things, she had no idea what she was doing practically. So it was a complete mess. And trust, this was great. This entire process was great. We have seen corporates in worse situations than this. So these wastes are obvious. You can understand lean. Lean, everyone understands. And this is all what you do. Now, we will get some technical jargons. We will try to understand how do you classify a waste. So when you look at a process, you try to understand that is this process a waste? Is this step a waste? Is this activity a waste? You will be able to categorize that waste. But everyone knows lean. When you talk about lean, everything that you mentioned here, technically, yes, that's what it is. Nothing that's just new or fancy about lean. Lean is very, very simple. Lean purely works on observation. So here, the core principle of lean is about observation. You look at your process and observe. What you see is what you fix with lean. Simple. Lean is always 100% observation based. It looks very, very simple, very, very obvious, but trust, it's very difficult to do simple things. Why? Because they're simple. We generally don't give that due importance. The answers to the biggest complex situation always comes from simple ideas. But unfortunately, since they are simple, we do not give value. Well, Six Sigma will look fascinating. Six Sigma is fascinating, trust, because the graph, charts, analysis, data, we always get fascinated with that. But trust, the basic foundation of everything is lean. Companies where they have excellent lean culture, Six Sigma will show its true colors. But if company has a weak lean culture, Six Sigma will struggle. It's very important to understand the foundation of any process improvement is always lean. It's absolutely common sense. It's non-negotiable. Whether you may want to do a Six Sigma, your choice. Six Sigma is a project. Lean is not a project. Lean is operations job. It's same boring task that you have to do every day without criticizing, without feeling bad about it, because you've got to do that. Simple as that. It's hygiene. It's non-negotiable. You must have a lean culture in your organization. Then you can think about Six Sigma. Six Sigma comes later because the foundation will always be laid down by lean. Lean is the most important, essential part of any process improvement. It's common sense, but it will do a lot of improvement in your process. If you just have your lean implemented, you will see a drastic change in your overall performance. But it's generally ignored because these are simple. We do not find that a big value add, but they're companies who are working just on lean. There's no Six Sigma, but they're doing great. They're world leaders. So it's very important to understand lean. It's not new. Everyone knows lean. It's commonsensical, but it needs practice because it's simple. It takes time for people to change their behavior. It's hygiene. And when we talk about lean, technically, when we overall the concept of lean, how do you identify a waste in case of a lean culture? We all understand, but technically, what do you call as a waste? So definition of waste, if you want to talk about, what do you call as waste in case of lean? What's your definition of waste? Any activity which adds no value to the customer or the process is a waste. Simple as that. It's neither helping the customer nor helping the process, will be categorized as a waste. And that is definitely a waste. Now, given that there are the lean part of it, lean, we'll talk about the origination, how did it start, but that's at later stage. When you talk about lean, it's all evolved from the Japan, when the Japanese version of waste was called as 7 types of waste. Now it's been like one more waste has been added to this to identify and categorize the waste. I would definitely request someone, in case you're aware of it, please to tell me what are these 8 waste in the system? How do you categorize waste? There's an acronym people use. Tim Woods, thank you. Thank you, Goldwyn. So Tim Woods is an easy acronym to remember and understand what do you call as a waste. So let's quickly go through this acronym so that we understand the entire process of waste identification. Whenever you go and observe your process, because lean is all about observation of the process from the beginning till the end. At every step, at every activity, you have to ask a question. Does it fall into any of these categories? If it falls into this category, then it's a waste. You have to find out, is every single activity done that you monitor, you note, is that activity something what we can call as a waste? What is T? What does T stands for? Anyone? I'm sure T stands for transportation, actually, transportation. I for inventory, perfect. M for, we'll elaborate this. We're just trying to get the labels here. W for waiting, perfect. O for the 2 O's here. Overproduction, yes. Next O, overprocessing. You're right about that. D for, that's, I guess, self-explanatory. D. No, not delay, defect or rework. S for, that's the 8th waste. The old version was the skills is unutilized skills. Let's expand everything and understand what you mean by Tim Woods. So remember, at every process step, you have to ask this question. Is it a transportation waste? Is it an inventory waste? Is it a motion waste? Is it waiting waste? Every process step, you have to quantify and understand, does that activity fit into any of these waste? If it's waste, then you've identified the waste. And when you identify, you go about eliminating it. First, let's understand what this transportation waste is all about. Any idea what is transportation waste? For people who have answered transportation, yes, I'm sure you know what is transportation waste, but we're good to hear from you. Transportation waste. What do you call as transportation waste? Moving to fridge? No, not moving to fridge. Not moving to fridge. That was not transportation waste. That was motion waste. Moving to fridge was motion waste. Unplanned routes. Yes, you're about that, right about that. It's unplanned and unnecessary movement of material or thing, of the material or thing, is what we call as transportation waste, not human movement. It's only about material or thing. That's more from a, like if you talk about a manufacturing sector, you might want to be shifting raw material. So we don't plan. It's basically lack of planning leads to this. We keep shifting material from one place to another. That uses resources of the organization. That could be using the trucks, cranes, and in case of like a civil construction stuff, where you see all of this, cranes, forklifts, and so on and so forth. In an IT world, what is this transportation waste? This is email traffic that you sort of end up getting lots of tons of email. That is again a transportation waste. Isn't it utilizing the resources of your organization? Yes, it's putting burden on the servers, it's putting burden on the internet, the power, everything. It's an email traffic. That's again a transportation waste. In an IT world, yes. In a manufacturing or kind of world, when you actually physically moving the material from one place to another, That is what we call as transportation waste, movement of material from one place to another. And like, say, for example, that's a township where we are trying to construct a building, like some sort of buildings, and we dump the raw material at one place. This is where we dumped all the raw material. And then we realized, oh, I'm sorry, but this place is where we will be erecting a tower, say tower number 1. Well, when we shift the material, we dump it here. Well, we realize, oh my God, that's the place for swimming pool later on. Well, you're going to shift the material here. We realize, oh my God, there's going to be a joggers park out here. Well, when sort of we keep shifting. Why? Because we don't plan. And that's what, if we don't plan, we will always be doing this unplanned movement. And that's what is transportation waste. Yeah, we will be all, Sachin will be all talking about the material shift that we'll be sharing and everything. So we'll come back to that by towards the end. Everything, be the recording, be the files and everything. We'll talk about that. Coming to the inventory part of it, very interesting. Anyone would like to pitch in what is an inventory waste here? Again, inventory. Overstocking, you're right about that, 100% right. This is something which is not required. Well, some bit of inventory is definitely required for manufacturing and completing your output. Well, that's not like having excess of that is over the, when you talk about inventory waste. Yes, let's understand this is a very, very important step in every organization where you got to look into this, and we'll talk a little more in more detail about this, because this is one of the, I would say, mother of waste. It will create a lot of waste in itself. Let's talk about it. This is unnecessary stocking up of inventory is what we call, and this is when we talk about raw material. When we talk about this raw material, this is not required, and we have stocked up this extra raw material. Hypothetically, the cost of that raw material is $10,000. That's the actual cost. Now, I have blocked my money as an investor, as a company stakeholder. My money, which is in circulation, is when I'm making money. If I purchase this raw material and now it's waiting because I'm not making money out of this till the time I don't use this, my money has been stocked up. It's dead inventory for now. So it's very important to understand, is it the only cost? We will talk about it. We'll get there, and we'll be getting there, the understock part of it. Well, is it the only cost of $10,000, or there's more hidden costs attached to it? Maintaining the stock, you're right about that. Here, holding cost, carrying cost, you're 100% right. Holding cost, carrying cost. What else? Insurance. What else? Security. Yes, you have to invest, like the people, resource who will be keeping the inventory, managing the inventory. There is a shelf life of the inventory. What if it gets expired? There's the obsolescence cost. But bottom line, things will, what we don't account for is this hidden cost. There's so much of hidden cost. It's not $10,000 only. There's much more to it. You have to keep it in some place where you will incur additional cost. There will be always a problem of this. It is very important for us to kind of keep this cost under control. If you have excess inventory, you will always get into this trouble of having this excess inventory. Well, let's understand who is the leading one. When we talk about inventory, just an example here, just to kind of make sure we understand, the best one in the world when it comes to lean concept is Toyota. Anyone knows how much inventory Toyota carries? The word lean came from Toyota. The lean was introduced by Toyota. They're the founders of lean. Anyone knows how much of inventory Toyota carries? Justin? Okay, so that's the approach. How much of inventory do they carry? Zero. You're right about that. 100% zero inventory. So zero inventory is what they carry. Well, let's understand that concept. And that's why I said we will talk a little bit more about it. They work with the concept of just in time. Rightly said. Yes, just in time approach. Just in time. And we'll quickly talk about this section a little bit more. What do you mean by just in time? We order exactly the right time when it's needed, at the right place, right quality, right quantity, and right price. Nothing more, nothing less. That's the concept they live and work with. Nothing before when it's needed, nothing after when it's needed. Right time, at the right place, at the right quality, in the right quantity, nothing more, nothing less. It's what they work with. But how they maintain, I'm sure there will be a lot of people who might be talking about this semiconductor shortage globally. There is a big crisis of the semiconductor. Then how come Toyota is able to manage that? Because they don't stock up inventory. So generally, why do you stock up inventory? To look into the inflation. What if there will be inflation and all those things? What if there's a supply chain disruption, which may happen because of different economic conditions globally? How do they manage their car production? If they don't stock up anything, zero inventory, well, these guys are very, very smart people. Let's understand this one. I'm talking about the old version. First of all, I'm talking about the old version of Toyota managing its inventory. Still a zero inventory concept, but an old version. So this is Toyota's hypothetical. This is Toyota's manufacturing facility where they manufacture. This has zero storage place. This is zero storage. This is 100% a manufacturing unit. Why? Because Toyota has very crystal clear understanding that we are a manufacturing firm. We are supposed to manufacture. It's not my job to stock up inventory. Well, it's the job of a supplier. Why should I keep inventory? I'm doing my job of manufacturing. Supplier should do his or her part of the job of keeping up the inventory. The contract team, when they sign up a contract with a supplier, they onboard a supplier, there was a clause, not the current one, that you have to be within 30 minutes of Toyota facility. We will not stock up inventory. If you have to do business with the Toyota, you have to be within 30 minutes drive of Toyota facility. Your offices may be anywhere in the world. I don't care. Your warehouses may be anywhere in the world. I don't care. You got to do business with Toyota, set up a warehouse within 30 minutes drive of Toyota facility. That was the contractual agreement they had to sign up. Well, people are dying to work with Toyota. That's a massive unit. Well, there are so many options. We can do it. If you fulfill this requirement, then it's good. Else, pretty much, you can find a way, my way or highway. Simple as that. Well, that was older version. What used to happen. So there are lots of these stores, not the stores, but car dealers. When cars are booked through the central system, what we call as the ERP system, they get to know how many cars are booked at different places. So they know, say, for example, 50 cars have been booked. Customer has paid a token money to the various car dealers. They know 50 cars have to be delivered. They will immediately relay this, that we need material worth how many? 50, not 49, not 51, exactly 50. Everyone must supply inventory worth 50 cars immediately within 30 minutes. Well, that was old version. That's no longer the one. 30 minutes was too much for them. This is the current version of Toyota. Current version of Toyota talks about, that's the Toyota facility. We will not wait for you to supply it for 30 minutes. There are 1,500 plus suppliers right on the boundary. They've rented this place. They're charging some money from these people. And yes, they have a contract with them. There are 1,500 plus suppliers. We will ask when we need it, just in time, we will procure it. Nothing before, nothing after. Immediately, you are on the fence of the Toyota facility. They are 1,500 plus suppliers. That's what they work with. We cannot wait for 30 minutes. That's too long for us. Well, just another element. Why would still they be kind of concerned about this? What if the supplier says, I don't have inventory, no semiconductors, there's global shortage? Well, no. When everything was normal, these Toyota people were smart enough to understand there could be market disruption, supply chain could get disrupted, and things may happen. When there was X price of a semiconductor for every spare part, they have a contract like this. If there was an X price, when things were normal, they were paying 10% extra to secure an exclusive contract. This was exclusive first right contract, first right with the original equipment manufacturer, with whosoever is manufacturing that equipment, the OEM, they signed up an exclusive contract, first right contract of the output which OEM will manufacture. First right is always of Toyota. Legally, they are bound because world was paying X, they were paying X plus 10. They secured this first time contract. Now, world is probably paying because of this shortage. World is ready to pay even 200% of it. They are still paying this. Why? Because they were smart enough to understand the market fluctuations. They're still paying this. Now, for a long period of time, yes, they paid 10% extra, but they were fine enough. They did their maths. They understood that even if you're paying 10% extra, I don't have to stock up inventory. I don't have to manage my resources, look into the shelf life and all those issues. So 10% extra paying, the 10% extra is still helping me manage the remaining costs, which I'm not bearing, my supplier is bearing. So they were happy with it. But now that has turned into a blessing for them because they are still paying that 10%, which is contract, but world doesn't have that exclusive contract. So whenever, if there are 100 chips manufactured, the leftover will go to the world. First right is always of Toyota. These guys were smart enough to understand it. So Toyota still works with zero inventory. Well, that's not everyone can do. Everyone is not Toyota. You're not so big. Sometimes companies are small scale companies. Sometimes are medium scale companies. You cannot dictate terms. Suppliers are too big at times and companies are small. So they work with safety stock. And now that's sort of a little off target. We can't get into that because how do you manage this inventory with safety stock? But I would definitely want to tell you what to look out for when you do consulting with various corporates. We do manage to get into the inventory part of it to minimize the waste of inventory, but that's the inventory waste. So you maintain just enough stock. And how do you do that? Well, there is an EOQ model, which we call as for calculation estimation of inventory, how much inventory. So we call it as economic order quantity. If you Google up, you'll find lots of literature. It's very simple formula, but it just to give you an idea, what does it mean? When you order in bulk, you pay a lesser price. When you order less, you pay a higher price. This economic order quantity formula will just give you right that sweet spot where you pay the lowest amount of money with lowest amount of inventory. That's what this economic order quantity model will help you learn. So it's you'll get lots of literature on Google. Just search it out. So people who are interested and who have anything to do with inventory management, do check out this. You will have your answers. Pretty much this is how a lot of people even do consulting in lean part of it. We definitely manage the inventory, and that's where it comes into EOQ model most likely. There are other models also, but this is where we still work with EOQ as a preferable option. There are more versions of this. We can go into that, but that's more from a detailed investing, like when we do a consulting work. But for now, again, that's what I would definitely recommend. If you are interested in inventory part, do check out this. It will be good thing to learn on Google. You'll get a lot of information. Coming to motion. Now, motion is unnecessary movement of people. Well, if you need to move, and this lady in that video was doing a lot of movement. If you need to do movement to do your job, that's motion waste. Movement basically of like bending, moving from one place to another. You're sharing the tools. So I walk out from my workstation, go to the next another person. So I'll try to give you a very simple example of so before I got into consulting, I'm just going to give you a quick heads up of what happened before I got into consulting. I was still engaged with a job with a corporate firm, and I was sort of doing parallel work with my consulting space before I got into full-time consulting. Just a quick one. This was a huge facility that we had a huge facility, and everyone had their printers. So this is that was a huge facility that we were working in, and that's where my cabin was most likely. Yeah, people used to complain that my printer has gone bad, this problem, that problem. Management was sick and tired, so they took away everyone's printer and they got a huge centralized printer placed somewhere here. So now, as a regular habit, you give a printout, get out from your system, pick up the printout. So I'll give a printout, get out from my system, walk through various cubicles, zigzag, hoping I did not stop and chit chat, go purposefully pick up a printout, come back and come back to my workstation. I did my maths, and this is where it was an eye opener for me. Well, just a quick maths, 3 minutes to go to the printer without stopping, without chit chatting, purposefully, and 3 minutes to come back. That's about 6 minutes wasted in a in picking up a printout. And that's what one activity of printout. And then on an average, they used to give about 3 printouts per day. That was more like an average. So on an average, 3 printouts per day, which will result about 18 minutes wasted. Who takes a measure count of this? Well, we don't care. We give a printout, get out from system. Who is kind of maintaining a log of how many minutes were wasted? Well, nobody does that maths. Well, I did it way back. So 18 minutes per day with 22 days, like Saturdays, Sundays off, with 22 working days in a month, about 396 minutes wasted. In 12 months, 4,752 minutes wasted. Convert that into hours divided by 60, 79.2 minutes wasted in a year divided by 8-hour shift, 9.9 days of salary in a year wasted just picking up a printout. And that had no value to the customer or to the company. And this is just me. Everyone in the organization is doing same sort of activities. And this is just one printout. There could be other activities. I'm doing a motion waste. But how do you figure out this? This is something which you can quantify. We cannot get into detail, but I'll definitely tell you what we do during consulting. Identification of problem is very important. Knowing how bad is the situation is almost 80% problem solved. You got to know how bad it is. So identification of problem will come from what we call as spaghetti diagram. Solution will come from U-shaped cellular layout. Let's quickly Google up and at least just get an idea about it, and you'll have your answer. It's that you have to do some bit of more search on this. You'll get your answers. There's tons of material on this one. This is spaghetti diagram. Why do motion waste happen? Because people occupied spaces without realizing that how my process moves. People just occupied. These are layout issues when people just occupy areas saying this is HR area, this is a finance area. These are layouts, these are motion tracking. So you do count every single step that you take. How long does it take? You count the steps and you count the time you had to spend in moving. And everyone has to so you look at different examples, there's tons of examples. These all examples of motion waste. When you look at these are layouts, we just occupied areas. These are where you track number of steps you've taken and you totally count like how much time did it take. And that is motion waste. Remember, everyone is doing this waste every day. And these are like lots of examples. All you got to do is look at some of these examples to get an idea. It's just that how you're moving, how your process is moving is going to tell you how bad is the process will be explained by how many times you cross each other's path. The more it's going to cross each other's path, that means you have lots of motion waste. One process step is crossing each other's process path. And this is what we need to cut down. And we talk about before and after cases. You will see a lot of before and after cases. When you just Google up, you'll find lots of examples. This is a very, very simplistic example. This is old process, post lean implementation. That's a simplified one. So all you got to do is avoid this crossovers, and this is what you achieve by implementing lean, and that's where less of motion waste. Your process is moving exactly in the same way. Your departments, you have occupied departments and areas based on how your process is moving, not you just occupy this department, and we don't realize how much of motion waste is happening. Solution is U-shaped. All Japanese companies have this U-shaped layout. Manufacturing facility, for that matter, service industry, this is what we are talking about. 1 to 2, 2 to 3, 3 to 4, 4 to 5. That's the process steps. And this is the U-shaped layout. All Japanese companies work with the U-shaped layout, whether it's a IT firm, whether it's a manufacturing firm, all these are U-shaped, all are U-shaped. Just got to understand this process will take more time if it's in a straight path and rather than a U-shape. People will do less. All these are U-shaped layout, all are. The tons of examples. All you got to do is understand my process steps should follow this sequence. If we got to understand, first draw the map and then have those process departments laid down, rather occupying the space and then saying, well, this is quality and this is so and so. You need a structural design change, and you do always in bits and pieces, one by one you shift over from this process to this kind of process. It needs quantification of problem. You got to tell the management that this is the amount of waste. You make some change and then show them the improvement. You make another change, again you show them improvement. You move step by step and switch to a U-shaped layout. You don't change everything one day. No, pretty much you move in one batch by batch. You keep shifting. So you can quantify the improvement. There are tons of examples. All you need to do is read some of them. You will have an understanding. That's a traditional, that's a U-shape. There is less of motion waste happening in this one. So it's more about realization of problem is more important than fixing, because when you realize 80% of your work is always solved. So fixing is not a problem. Knowing how bad is the problem is the first step to success. That was on the motion part. Now coming to weighting. Now weighting is self-explanatory because lean is all about cutting down the time. We don't want to be waiting because lean is speed of the process, lesser time. And when there is a process step A completed, B did not start, then why? Waiting for what is what you need to understand. Waiting for raw material, waiting for instructions, waiting for approvals, waiting for resources, what? We're waiting for work in progress inventory, where one process step has created an output. There's another process step, there's an inventory in between. And we'll look at some of the examples. Let me quickly pull out one image so that we can understand what we're talking about. We do create a lot of material in case of, let me quickly show you that one, so that at least when we talk about implementation of lean, we do work on this. A value stream mapping is what we created. That's just more from a extensive classes when you get into one, but let's quickly have a look at an image so that we are clear about what you end up creating. That's what we say. A process step completed. B it from A to B. When you're moving, there is inventory which is waiting for this process step to process, because this process step has completed an activity and that's waiting for this process step to work on. This process has completed the activity and this is waiting to be processed by this. So there is inventory which is waiting to be processed. Again, a waiting waste is there in between the process steps. So you have lots of such waiting issues. All you got to do is fix this process one by one and find out waste. You will never be implementing lean full throttle and change everything. No, it always happens in a very, very subtle way, in a phase manner, like phase 1, phase 2, phase 3, and you keep doing it. It's never ending. So you keep finding the waste, and you keep eliminating waste, you keep prioritizing waste, and you keep eliminating. It's never ending desire. You'll never ever be able to remove all the waste from the process. Coming to overproduction, well, it's self-explanatory. Well, this is finished good. You had, congratulations, you had extra raw material here. We were talking about like $10,000, which was actual cost. Now you have worked on it. This is finished goods. This is waiting to be sold, but it's still waiting because there's no demand. Now the worth of this finished good is $50,000 because you have invested the raw material, the resource cost, everything has been invested. The MRP, the maximum retail price for which it will be sold, is worth 50,000. Now it's waiting, sitting in your warehouse. Same hidden cost still applies with the cost of storage, cost of resources, cost of carrying, holding, shelf life, all those extra waste which we don't account for. These are hidden costs inbuilt in the system. You are living dangerously. Why? Because market demand changes. What if the trend changes? What if there's no more requirement of the kind of product you manufacture? It becomes out-fashioned, where it happens a lot. This is dynamic market. And then you will be left with this inventory. We worked for a publication house in Europe, and this publication house has 7 million euros worth of book, which they have accumulated over a period of last 10 years. They're one of the major publication house in Europe. So whenever there's a bestseller book, they print a lot of copies of that bestseller book. And obviously that they keep selling, keep printing. And then they have the market trend changes. The new bestseller comes in, the sales of that old one is less. Now that gets stocked up in their warehouse. So we counted the inventory for them. And this inventory, which was sitting in the warehouse, was about 7 million euros. Accumulated for a year, like about 10 years time frame. And that inventory is it the only cost? No, there's an opportunity cost, there is a storage cost, and they are wasting on that money. So practically, if you do overproduction, you will be a victim of lots of waste. You will be creating a lot of waste. And that's what good organizations will never get into, like Toyota, because you don't have extra inventory, so never overproduce. Overprocessing is self-explanatory. Why? Because when you talk about overprocessing, when does it happen? When we do not understand the customer requirement clearly. We end up overprocessing and doing it more. In that example, this lady overprocessed because she did not understand the requirement, or we try to overdo something just to excite and delight the customer. But that is again taking more than what the customer demanded. Well, that is going to take more time because you're over processing what is not demanded. Say you learn Lean Six Sigma, great job. You know project management, you know quality management, you know statistical studies and everything. You are a perfect project manager. You can solve business problems. Your boss asks for some sort of data. Now, what you do is you use all your analysis and tools and to analyze data, and you share a complete presentation with your boss. Well, did I ask for that? No. Why did you overprocess? So delivering more than what is needed, but that's going to be overprocessing. So it's very important to understand and baseline your process so you don't overprocess. And that's what happens in general when you don't understand what is demanded. Requirement analysis is very important in any industry, not just Lean Six Sigma, any industry. And that will lead to overprocessing if we don't do it. This is self-explanatory when we talk about defects or reworks, because if you have a defect, then you will be working again to fix it. Say, if you have an output, like you manufactured a product, it is completely damaged, then you lose their money and you have to rework and make one more. Or it's partially damaged, then you have to fix and rework it. Bottom line, you'll be working again, but without getting paid twice. So here, if you have defects in the process, you will be working again without getting paid. Your process steps will be waiting because your process should have been completed. Your process steps will be creating a waiting waste. Why waiting waste? Because you will be reworking on it. This will again be waiting waste will be created because you have defects. You have defects, your process has to wait to complete the entire chain because you are still working on something which should have been complete in the first go. That will create more waste. So one defect creates much more waste than we just about fixing the process. No, there'll be much more waste created than that. When you talk about skills, it is technically when you talk about you're not utilizing the talent resources completely. This is more about micromanagement as well. When you do not utilize your resources properly, you end up creating this talent and skills waste. A simple example, say I wanted to hire somebody for my Lean Six Sigma project. I asked my HR to get me a person who has a PMP certification, must be a Six Sigma black belt. It'll be great if this person knows robotic process automation and will be added advantage if this guy knows agile methodology and probably some sort of ISO standards also. Well, I had every possible requirement in the world. Fortunately, I got one person as well. And when I hired this person, I tell this person, do as I say. Well, if you needed a clerk, you should have hired a clerk. You're wasting the talent. You got a brilliant resource. Please trust your own judgment. You hired somebody who's so brilliant. You got to give that respect to the talent. You got to give the chances to make sure that the people can reciprocate. Well, this person is immensely talented. If you're not utilizing talent, you are creating a waste. And obviously, you would never be able to win the trust as a leader. You'll always be in a struggling situation because you suffocate people. I understand some bit of management is okay, but over management is when you suffocate your staff, and that's what is bad. These kind of managers will always be in a firefighting situation because they will never have a backing of the team members because they never showed that trust. You don't show the trust, you don't get reciprocated. It's very important to give that due credit, to give the knowledge, to give the chances to the people so they can do well. It's very important to understand as a leader, as a manager, if my team does well, I don't have to talk about how well did I do. My team's performance is my performance. I don't have to be credit hungry and steal away the credit of people. And that's what people do who tend to micromanage. They always try to steal away the credit of the team and they say, well, that's what I did. No, a true leader will always try to give chances to the team, and your team's performance speaks volume of how good you are. So practically, it's more about if you're not utilizing the talent, you will be creating this waste. All this while, when you're talking about lean part of it, at every process step, you got to go and ask, am I doing these waste. Every process step. Is this activity? Can you categorize this activity as transportation, as inventory waste, as a motion waste? And one activity can fall into multiple waste. That's fine. All I need to do, understand where is the waste happening in the system, because lean starts with identification. When you identify, most of your work is done, because then you keep eliminating gradually. It's never a full throttle process. Gradually, you keep eliminating it. That's what you do with lean. Well, just a quick check. Is everyone fine with lean part? Is it okay about lean? All right. So we're done with the lean part. We'll get into now Six Sigma. Now, Six Sigma is a different ball game altogether. I would not say the same thing about Six Sigma, that yes, I won't, like some of us might be already into the role of managing various process metrics. You might have been exposed to Six Sigma or something like Six Sigma, but it'll be good to know, what is your definition of Six Sigma? Manish, there's no break in between this one. Like, we will have a break later. Variance reduction, Richard, thank you. And I guess before that, we also had an answer from Mr. Kitso. Yes, absolutely, yes. If your answer doesn't have this word reducing variation, it's not correct. It will be incomplete. So both of your answers, when you got these answers, yes, everyone has answered it correctly. The actual meaning of Six Sigma, unless you have a word variation in your response, it is incomplete. So full credits to you for answering it 100% correct. There's nothing more which is required when you mention the word variation, because Six Sigma is all about reducing the variation. Let's understand what is this. Again, a quick, simple one. It's a statistical approach to reduce variation. And I write this variation, I'll write down defect as well, to improve effectiveness of the process. Well, simple as that. Let's understand, let's break down the sentence again to understand what do you mean by this, all these terms. First of all, let's pick up the word effectiveness. What do we mean by improving effectiveness? Well, it's a fancy word. Effectiveness is nothing other than the quality percentage. What is your quality percentage? So let's understand now, read in the language of quality percentage. If we talk about what is the process quality, well, if I implement Six Sigma, it says it improves the quality. Great job. That's what it does. How do you do it? By reducing the variation, which I've mentioned as defect. We'll talk about what is variation, but simple. If you reduce the defect, your quality improves. This very, very basic common sense. If your defect goes down, your quality improves. But how would you reduce your defect? How would you reduce your variation? By statistical approach, data-driven. Six Sigma is completely a data-driven methodology. And that's a new slogan. Everyone, like we usually say, data is the new oil. And that's what is the current, the way market is trending. Everyone wants to capture data. You install one application in your mobile. This application wants to know everything, your contact details, your for that matter, your messages, wants to access everything. Why? Because the future is data. People who will understand data, to use the data, people will be able to control the world. And that's what everyone is going crazy after data. It has lots and lots of inputs in it. So yes, Robert, yes, we will be getting into all that notes related stuff, everything will be discussed. Yeah, so Michelle is going to give you all that, the details, how it will be shared and everything, about the recordings and everything will be discussed. So coming back to this one. So let's talk about a simple one, like just taking a very, very simple example. I have a client which has given me an order to manufacture, say, a 5.5 inches long whiteboard marker. Very simple, like just keeping it very, very simple, generic, so we can understand the concept. So as a manufacturer, I understand how this mark, like what is the target. So I have manufactured some markers, which is now this. Oops, my bad. Now it's fine. I have manufactured few markers as of now, and this is what the length of the markers is. And let me just make some 5.5 out of here. So because I've randomly created these numbers, okay, let's kind of keep it this way. Now, let's understand the variation part. Is this 5.5? No, that's a variation from 5.5. It's bigger than 5.5. It will be called as a defect. Is this 5.5? No, that's again a variation from 5.5. This will be called as a defect. Well, this is good. This is variation from 0.5 to 5.5. It's a defect. This all is good. And we have, this is high variation on higher side, variation on higher side, variation on lower side. So anything which is more or less than the target is a variation. Anything plus minus of the target will be variation, and that will be treated as a defect. So when Six Sigma comes into picture, when you have tried, tested, and failed, you tried everything, but it's not working out for you. You have experts in every organization. If you have used your experts, you've used your lean, where lean ends, Six Sigma journey will start there. So Six Sigma comes after lean. Remember this, where you have exhausted everything, your lean knowledge, your Six Sigma, your basic process experts, technical experts. You probably have manufactured, you might be able to solve the problem, but again, the problem resurfaces. You solve the problem, 2-3 months, everything is fine. Again, you start seeing the problem. It is a chronic problem. You don't know what to do. You have tried, tested, and exhausted every possible source. Your experts even don't have any answer. That's when Six Sigma is required. When Six Sigma is required, remember what we said, lean. Lean is based on observation. You fix what you see in lean. What you when visually see, you go to the process, you see the process, and you find, well, it's not working right. Well, that's what you fix with lean. What you see and you find, well, this is not good, you fix with lean. What do you fix with Six Sigma? What you don't see, what you cannot explain, you experience a problem but can't explain why. You have tried, tested everything, but you are not able to understand why this is happening. That's when, so Six Sigma comes in when everything has failed. It's the last resort. Well, you have tried, tested, and failed everything. Well, I see a problem happening in front of me. Yes. Do I see defects? Yes. It's getting out of control. Yes. I'm not able to do anything about it. I've tried everything and I have no more means to solve it. That's when Six Sigma is required, the last resort, when you get into details. Well, it's not what you see. It's not visible to you. That's what we fix with Six Sigma. You have to get detailed. You have to go in the real bottom of the problem. You need Six Sigma. What you see is what you fix with lean. Remember, Six Sigma is not something which you generally use. It is always the last choice after you've tried and failed everything. Now, anyone wants to tell me, like, what is the Six Sigma performance standard? If I say my process is working at Six Sigma level, what is the performance level at Six Sigma in terms of quality percentage? Anyone is aware of it? What is my process quality? Not 99.7. Not 99.7. If in talk about in the percentage part, if I say my process is working at Six Sigma level, what is the quality percentage? These numbers have to be memorized by heart. 3.4 in what? Process quality percentage, or any other way you want to explain Six Sigma in numbers. In 1 million, 3.4 per million. Thank you. Okay, perfect. The quality of process in terms of quality percentage is 99.99966%. That's in terms of quality percentage. If your process is working at Six Sigma level, your quality percentage will be 99.99966%. And if I talk about in the language of defect, when your process is working at Six Sigma level, what will be your defect rate? And that's what rightly said, it's 3.4 DPMO or 3.4 ppm. Let's understand what's that. 3.4 DPMO means 3.4 per defects per million opportunities. 3.4 parts per million. Now, bottom line, you may say it either which ways. It's telling you the performance level at Six Sigma. What it means, your process, if it's working at Six Sigma level, would have a quality percentage of 99.99966% out of 100. But if I talk about at the same quality level, what will be my defect rate? And in case of Six Sigma, everything is measured on a million scale. So it says if your process is working at 6 sigma level, your process will maximum make a defect of 3.4 in 1 million opportunities. If you're manufacturing 1 million markers, the maximum probability of having a defective marker is just 3.4 in 1 million. It's almost like a zero defect. Well, it's important to understand and remember these numbers because recruiters do ask this question during job interviews. These numbers are specific to Six Sigma. So please memorize these values because this will be important. In 1 million transactions, 1 million opportunities, the maximum probability of making a defect is just 3.4, almost like a zero defect. What is 3.4 in 1 million? Well, just a quick question I would like to ask from you. Is 99% quality good? 99% quality? I would say if my process is working at 99% quality, is it good quality? In general, we say it's a good quality. In general, yes. Let's see. How good is 99% quality? What is the 99% quality means? Pass percentage is 99 out of 100. That's what 99% quality means. And fail percentage says 1 out of 100. That is what we mean by 99%. Like means 99 is good quality and 1% is defect in the process. At the same rate, at 99% quality, how many defects will I make in 1 million? At 99%, if I make one error out of 100, then how many defects will I make in 1 million, which is 6 zeros? If one defect out of 100, then how many defects will I make in 1 million at the 99% quality? Basic maths. If one error out of 100, then how many errors out of 1 million? How many errors are we talking about? If I make one error out of 100, then how many errors will I make in 1 million? No. If I add the 99, if I make one error out of 100, 10,000 errors out of million. If my process quality is 99%, see, if I make one error out of 100, so just cancel the zeros, you get 1 out of 100. You will make 10,000, same rate. If you just cancel these 4 zeros from here, you'll get 1 out of 100. If you make 1 out of 100, then you'll be making 10,000 errors out of 1 million. And if your process is 99% quality, what we're comparing it with at 6 sigma level, 3.4 in 1 million. These are two worlds apart. There's no comparison in 6 sigma and 99%. Once upon a time, it was a great performance level at 99%. It's bad. Will be history if your process is working at 99% quality. In current scenario, the customer has become so intolerant, the customer will not give you a second chance. Customer will not like to have a defect in the process, any product or service. You are just an option. If you're a manufacturer, if you're a service provider, customer will not give you a second chance. You are all as an option. So customer will switch over to a different provider if the customer experiences a defect. And that's why globally, every corporate is switching towards zero defect. Why? Because they do not want to become a history. There are tons of examples. You have Nokia, you have BlackBerry, you have tons of examples. They were great brands, but they could not understand the changing dynamics of the market. This customer is very intolerant. One error, they will wipe you out because so many options are available. And that's what markets, corporates, industry leaders have understood what is the importance of Six Sigma. And that's why globally, people are switching because this is a phenomenal level of quality where your customer will be very, very, very happy about your performance. You'll be rarely any defect in the process. But a quick question. What is this sigma level? Technically, when we say Six Sigma, what is the sigma level? Well, it's weird. It's a defect measuring scale. Just a quick question again. Is there any company? Well, we're not talking about Six Sigma now. I would like to understand, is there any company, have you heard about anything better than Six Sigma? Or is it the best you can get? Is it the best Sigma level or can we get better than Six Sigma? Have you heard about anything better than Six Sigma? Or is it the best we can get? Have you heard anyone heard about better than Six Sigma? Anything better than, is it possible to have 7, 8, 9, 10? Anyone heard about anything better than Six Sigma? Are there any industry? Have you heard about it? Like something like that? Yes, we have. Six Sigma is not the best Sigma level. And let's understand, that's why it's important to understand what is the Sigma level. We got to, and we'll also then understand, then why are we studying Six Sigma when they're better Sigmas? Then why are we studying Six Sigma? Why not 7 Sigma? Why not 8 Sigma when they're better Sigmas? Yes, it's a Sigma is a, as I've written, Sigma is a defect measuring scale. This scale goes in both the direction, positive and negative. So can there be a negative Sigma? 100% yes. You can have negative Sigmas in the process. Absolutely, you can have negative Sigmas. Now let's understand what you mean by these Sigma levels as such. Technically, when we say my process is working at 6 Sigma level, when if your process is making just 3.4 defects in 1 million, we say your process is working at 6 Sigma level. Let's understand the basic concept, right? If your process is creating lesser defect, your Sigma level increases. Sigma level and defects are reciprocal, they are opposite. So aviation industry, when talk about aviation, it's working at 12 Sigma. When we talk about nuclear reactors, for that matter, NASA, the space program, all these are around 12 Sigma level. Now, pharmaceutical industry, around 11 Sigma. Why these industries are at higher Sigma level? Because it's a need of the industry. Well, these are critical industries. Why are we so concerned about, like, just think about a situation. Would you be happy boarding a flight when you know out of 1 million flight, 3.4 will crash? No one would love to board a flight when we know that's the failure rate, because one error is a big, huge error. So many people can die. It's a huge cost, and plus so many people. Life is at stake. Six Sigma is a horrible Sigma for aviation Sigma. Well, aviation industry cannot operate with Six Sigma. It's bad Sigma for them. Pharmaceutical industry, why there's so much of problem with COVID vaccine? Just make vaccine and give it to everyone. No, one wrong vaccine and so many people can die, and that's irreparable damage. These are critical industries, and there's no way Six Sigma will work for them. Six Sigma is bad Sigma for them. They have to be higher. They have to be better than Six Sigma. So technically, at higher Sigma levels, you have lesser defects. So it's so if defects reduces, Sigma level goes up. Generally, why can't everyone work with beyond Six Sigma? Why are we talking about Six Sigma standard? Why? Because beyond Six Sigma, technically, you need automation. It's very, very difficult. It's almost next to impossible to remove human errors. We are bound to make mistakes. Human errors will always be there. So it's very difficult to reduce any more defect beyond this. So you generally need automation to take it beyond Six Sigma. So these industries will 100% be on automation phase, because automation will take away the human error. Robotics will come into picture, and that will take away the error possibility to a very, very, now we're talking about in million, that could be talking about in billion, one error in a billion opportunity. That's why we take it beyond when you use automation. Technically, not every one company wants to get into higher Sigma. Why? It doesn't matter. To get into automation, you have to spend millions and millions of dollars. Do you think this manufacturing company of marker will get into automation? No. If I get to Six Sigma with basic project management, quality management, statistics tools, well, there's no point in getting beyond Six Sigma. There's no fun. It doesn't make sense, because to invest in automation, I will spend millions of dollars. But what will I save? 3.4 markers? Well, what's the cost of 3.4 markers? Doesn't make sense. So even if I'm getting to a Six Sigma, well, that's phenomenal for every other industry. This is benchmark. Everyone wants to get to a Six Sigma, because these are other industries are critical industries. They have to spend that kind of money, because every error is a big, huge error. That's a crime, I would say, to make an error in these industries. These are critical ones. So you have to spend a lot in automation to get the performance level there. Bottom line, when you process Sigma level, the defect is, if defects increases, Sigma level drops. Simple as that. It's reverse. So if your defects increases, your Sigma level will drop in case of like any kind of performance metric, and it will show you the different ways of calculating sigma level. Given that it's a webinar, we cannot get into so many ways because you have to get into lots of statistical stuff which you have to understand before that. So I will at least tell you one simplest way how sigma level gets calculated, and this is only one method. There's so many different ways how sigma level gets calculated, but I'll tell you one of it right now just to make sure we understand this process. Let's calculate this one, understand how Six Sigma works, and we will be able to understand like the calculation of sigma level. And this is, as I said, only one method. We can't get into the explanation of this because again, that needs some bit of statistical knowledge before that. But if somebody gives you a defect rate and wants to find sigma level at so and so defect rate, what's my sigma level? We can do that. There is sigma level called Z for sigma, LT for long term. There's something called long-term sigma. We cannot get into explanation of that, what's that, but there is something called long-term sigma, which is what we have here. There's something called short-term sigma, Z for sigma, ST for short-term. This is called short-term or current sigma level. Well, let's understand the difference here. This is calculated an actual sigma, basically. This is the calculated sigma and the actual one. The other one is used for reporting and communication. So whenever people talk about any sigma level, they always talk in the language of, if you're preparing reports for your process sigma level, when you're telling somebody, well, process is so and so sigma level, you always use the short term or current sigma level. This is for communication and reporting. This is the actual one, and we'll understand how to get there. The formula, I'm going to leave it right here, show it here so that you know. Norm sin V, 1 minus defects divided by total. That's the formula I will use right now. And this is short-term sigma is equal to long-term sigma plus a fixed component of 1.5. Again, that we cannot like get into the discussion why 1.5, because that needs almost like 30 to 35 minutes discussion. And before that, we should have a lot of other idea about statistics. So for now, but remember, that's a rule. Y part is more from a discussion perspective, but that's how sigma level gets calculated. So let's start with some bit of examples to understand it. Say my process has 17% any random number, 17% defects. What is the sigma level? So I will calculate this first. Norm sin V, same formula, 1 minus, what's my defect in the process? 17%. So 17 out of 100, close the bracket, close the bracket. That's long-term sigma. You will not report this sigma level. What you will report is long-term plus 1.5. This 1.5 is fixed constant value. So you will say my process sigma level is 2.45 at 17% defect rate. Let's pick up some more examples so understand this concept. Well, why leave 6 sigma? Let's validate 6 sigma. 3.4 defects in 1 million. We say that's when my process is working at 6 sigma level. Norm sin V, 1 minus 3.4 defects in 1 million. 4, 5, 6 zeros. And plus 1.5 will give me 6 sigma. So we don't say 4.5 long term, we say 6 sigma current. Your process current sigma level is 6 sigma. So you always report this one. This is not used for reporting. This is used for reporting, publishing, talking to people. We always use the current sigma level. That's a culture. Let's say if your process has, if I did some audit, some random audit, I found these many errors out of, say, these many things that are audited. I audited these many transactions or anything. This was the error rate. Let's calculate norm sin V. 1 minus, what was this number? 1587 out of 268,565. That's it, close. And that will be plus 1.5. I'll report my sigma level as 4.02. Let's take a couple of them, couple of more. So if my process is working at 50% defect rate, randomly, 50% defect rate, what is the sigma level of the process? Norm sin V, 1 minus 50 by 100, 0 sigma, it will be 0. And plus 50% is 0 sigma long term, but will be reported as 1.5 sigma. And if my process has, say, 75% defect rate, hypothetically, it will be negative sigma. Let's say norm sin B. The moment defect rate is more than 50%, it becomes negative. So it's 75 out of 100. You'll see negative sigma. That's the negative one, but will be reported as plus 1.5, 0.83 sigma. Last but not the least, say, for example, I'm trying to find my office reporting time sigma level. For 30 days, I tracked my time. I was late in reaching office 4 days out of 30 days. Like that was my office reporting time sigma level, attendance sigma level, whatever. That's my sigma level. Let's find it out. What's the sigma level for my office reporting timing? You can calculate sigma level for anything that comes to your mind. There's no limit to it. That's the long term. And I would say my office reporting time sigma level is 2.61. So that's one way. Trust, this is one way. There's manual methods, there are formula-based methods, there are Minitab-based methods, there are tons of ways. And this is the simplest out of all of them, because even for this, if we get into details, there's been a lot of discussion, which is not possible from a yellow bill perspective. But what is the meaning of the formula? Why 1.5? What is long term? What short term? Many things have to be discussed. So, but for now, at least you know the method, how it's done. Only thing which is left out is explanation. So, bottom line, by now you could have at least figured this out very clearly. Lean is all about observation. What you see, what you fix with lean. When lean ends, when lean fails, that's when Six Sigma steps in. It's where you have tried, tested, and failed, and you cannot solve it. You've reached a standstill. There's no more answers that you have. You can't explain why. I've exhausted everything. I don't know how to fix this problem. Then you need Six Sigma, which will get you to this level. A phenomenal change in your performance will come with Six Sigma. That's going to make you market leader. And that's where, but bottom line, remember, Six Sigma is not the best one. There are better Sigma levels, and industries are working at higher Sigma level. But it's just that one company can have so many Sigma levels for every metric. I can calculate Sigma level for handling time. I can calculate Sigma level for attrition. I can calculate Sigma level for attendance. I can calculate Sigma level for cost. And one company can have hundreds of Sigma levels, and different metrics. I may be at different Sigma level. In some metric, I may be at 6 Sigma, 7 Sigma. In some metric, I may be 2 Sigma. It may vary depending on what's my defect rate in the process. But I hope it is okay and clear so far, everyone. Is it fine with everyone? Quick one, just a quick confirmation. All right, so I guess we are going good. Let's then move ahead then. DMAG frameworks. When you implement Six Sigma, you implement in 5 different phases: D, M, A, I, and C. 5 different phases. DMAG, D stands for define, measure, analyze, improve, and control. 5 different phases. Now let's quickly have a look at what you do in each phase. Define phase is all about selecting the right project. You may be facing so many business problems, but you cannot solve every problem with one single project. So selection of the most important project is what is done in define phase. This is all about project management. So if you come from project management background, or if you have PMP syllabus understood, you've done a Prince 2, you already know a lot of stuff about define phase. It's all about project management. Any which ways, we learn everything from scratch in define phase, everything, which is all about project management skills. Measure phase is collecting reliable data for analysis. Well, you baseline your process, you understand how bad is the situation. Bottom line, you got to have reliable data, because Six Sigma is all about data-driven analysis. If your data is wrong, then pretty much everything will be wrong. So it's data authenticity, reliability, process baseline, everything is done here. This is about quality management, and statistics comes back here. So statistics comes here. Analyze phase is all about using statistical tools and techniques to find out real root cause, why you're facing a problem. We have not been able to figure out through regular means, but now Six Sigma will help you drill down and statistically help you understand what is exactly causing the problem. Well, that's what needs quality management and statistics again. And improve phase, you achieve the target. Management would have given you a project to achieve some target, like improve the quality, reduce the cost, improve the net promoter score. Could be different kind of targets. Well, achieve that. And finally, control phase is all about sustained improvement. Beauty about Six Sigma project is when you improve something, it will always stay improved. It will never fall back thanks to control phase. Its quality performance is sustained in the level. What happens in Lean Six Sigma? Traditional projects will show you immediate improvement and then there is a decline. Six Sigma doesn't work this way. You have a project, you improve, you the improvement phase, and there's a control phase, which is sustained. You sustain this level. The process DNA is changed and sustained. This level is sustained. Now you cannot go back. You cannot fall back here. But this level has been sustained and controlled through statistical methods. Now you pick up a new project, again achieve the target, again sustain. There's always it's a step ladder approach. You sustain this level. Now you're not going to fall back to this one because your DNA has changed for the process. Again, you improve, again a sustain, improve, sustain, improve, sustain. So it's a sequence of projects which will happen one after another. But the beauty is about we never fall back. If you improve, you always sustain through the control phase. That's what is most important element when you talk about Lean Six Sigma implementation. You always secure the gain. You never lose that gain ever because of the statistical process control, which is in the place. While you're working on this DMAIC, very importantly, apart from the statistical tools and techniques, you use some of the 7 quality control tools, which we talk about 7 QC tools. People talk about 7 QC tools. So these are more from a graphical analysis, graphical tools people use. Simple tools of analysis, I would say, but more complex one will be statistical ones. So this is the 2 ways you go about analyzing the data. One is about using these simple tools, and other ones are about these kind of tools when we talk about statistical studies, where you analyze the data completely with the help of, so you use the statistical tools, the graphical tools, which is something like we talked about. I'll show you. This is, okay, let's have a look at this. These are all Minitab based output. I said it's completely filled. Yeah. So look at this. These are all statistical tests that we'll be performing. With different kind of data, we'll have different kind of statistical tests. And that's when you end up performing. This is all. So you use statistical, this is high-end statistical tools when you use, and there's some which are basic ones are the 7 quality control tools. So when you talk about statistical tools, there will be different ways how you use statistics. Some will be, this is hardcore statistics when you use, and this is simple. Trust, stats is very, very simple. I'm bad at maths, really, really bad at maths. It doesn't matter, but stats is very interesting and very easy as well. So maths has a lot of variations and stats happens to be one part of it, which is very interesting. Thanks to Excel, Minitab, it has made job easier. If I would have been talking about this about 10 or 12 years or 15 years ago, yes, then you should have got good knowledge of mathematics, statistics. Well, thanks nowadays we have Excel, even is great statistical tool. Plus we have Minitab any which was. After that, you don't need anything else. Bottom line, when you talk about 7, these are basic ones, and there are more advanced ones, which are the statistical tests. But what these 7 quality control tools are, first let's kind of list them down. Histogram, check sheets, flow charts. We talk about Pareto chart, scatter plot, fishbone diagram, and control charts. Let's quickly talk about these one by one. These are 7 quality controls globally used by every industry. Now, histogram. What is histogram? Let's quickly have a look at this. What do you mean by histogram here? When you want to analyze the process, I will use Minitab for this one just to explain what is a histogram here. So we can understand and analyze this data. Let me quickly. So as I said, we shared the data files with the participants to work on projects. So I'm going to pick up one of the projects file that people work on. It's completely experiential stuff. So we'll be kind of using this entire, let me just copy paste this one. Right. So this is where we talk about, I'm going to analyze this by histogram. We will be able to understand what's histogram when we look at the data. So I can create the histogram here. There are various ways you do it. Histogram, what do you study with a histogram? We'll try to understand just a basic way about what histogram looks like, and there are different ways of looking at histogram. What information does it tell me? Well, when I plot my histogram, it tells me my process mean, where's the centering, where's my process average, the average of the process. This is where my data looks like. the variation, my process can swing lowest up to this, maximum up to this. It gives me a lot of information. So when I'm trying to find out how my data looks like, if I used my historical data, it helps me understand where's the center, where's the average of my data, and how much of variation my process is likely to expand in the process. So histogram comes up with lots of variations. We look at histogram from analysis perspective. It's a lot of things, a lot of tools are there. It helps you understand the data in absolute control. This is where, again, histogram, but a lot of analysis, future predictions, all of it is available using histogram. So you can analyze data in, like, this is about the historically, and this is more about future as well, how likely the process is about to swing both ways with lows and highs. You get into all those details. So histogram, when you look at histogram, it's more about analyzing. Okay, give me 1 quick second. Oops, 1 second. That's fine. So it helps us understand the process mean or average, process average, and the variations the process is likely to. Even this, for example, well, later on when we get into details, it's more about even to calculate sigma level, you need histogram. It's a basics minimum element. So entire statistics boil down to histogram. When you start analyzing the process data, first thing you always look at histogram for analyzing the process. Very, very important tool. And as I said, even to calculate sigma level, you need a histogram. Check sheets are, everyone has used check sheets. These are any template in which you record data. For analysis. For analysis, you need to store data in some format, some template, and that's his check sheet. But this is any format. Let's say a data collection sheet, audit sheet, attendance sheet, a to-do list, any kind of performance, any data where you record your data is your check sheet. And if you go and check out check sheets, for you to analyze, you've got to save data somewhere, maintain data. That's all check sheets. You customize your own check sheets in the way you want, the way you like. It can be any format. It could be numbers, it could be text, it could be anything. These are all examples of check sheets. You define your check sheets, your project, you understand your business better. You customize your own check sheet. You want to have check sheet in this format? Well, that's your choice, completely your choice. You customize your check sheet, how you need to collect the data for analysis. Flow charts, well, to find out waste in the process, well, you need to make a flow chart. You need to work on a flow chart to create and identify the waste. And Lean Six Sigma, we work on multiple flow charts. We talk about something called SIPOC chart. We talk about value stream mapping. Well, value stream map is what I showed you earlier. There's when you was showing this, the lean part of it, like this is. Give me 1 quick second. That was a value stream map to identify the waste in the process. You have here, that's a value stream map. That's flow charting to understand the process waste. Where is the waste happening in the process? A lot of things are there. You look at the process waste identification. You look into various kind of waste identification is done. You got to have your process map. So flow charts are essential to identify waste. To implement lean, you must have it. Pareto chart is also known as 80-20 rule. Well, 80-20 rule, why? Because this gentleman, there was somebody by the name of Alfred Wilfred Pareto, Italian guy. This guy was given a responsibility by the king at that point in time to do some bit of research and come back and give us the detail about wealth distribution, how the wealth is distributed in the entire kingdom. And this guy came back with an eye-opener for everyone that 80% of the wealth was controlled by 20% people. And that was an eye-opener for everyone. So people wanted to understand how to, this was later on used for in journal also about industrial purposes. And we saw that most of the problems actually come from 20%, so 80% of problems come from 20% reasons. Let's see how do we make a flow chart, the Pareto chart on Excel. But before that, I guess there's a quick question. Let's please correct this one. Okay, let me just check this out. Which one? You need to make a flow chart. Thank you. Okay. That's the data. So we have been getting customer complaints about missing different kind of complaints, and these were the number of times the customer have complained, say last 2-3 months. Pareto chart helps you to figure out which problems to focus on. That's what it's like. So it's a prioritization tool by the count based selection, which project needs to be prioritized. You may end up making a Pareto chart. So if we make a Pareto chart, this is how it looks like. That's what it looks like, Pareto chart. Well, let's keep this aside, and I'll try to create this on Excel right away, just to give you an idea how to do it on Excel as well. So we can parallel talk about that as well. Let's go and check this out. So in Minitab, I just copy and pasted this data. I did not have to, don't have to do anything. It's a smart software. It was up and down, doesn't matter in Minitab. It will still create a Pareto chart for you. You don't need to do it. But in Excel, well, you have to do some bit of work. Let's kind of sort the data in descending order, largest on the top, smallest at the bottom. And that's when you take some of these complaints, take the sum of these complaints here, 423. What's the individual count, individual percentage? What is this 274 out of the total number of complaints, 423? And I'll freeze by this cell of 423 by pressing F4 on my cell. That will get a $ in front of both of them. It will lock this 423 cell. So that's where I copy and paste this formula. It'll give me individual. So this is 59 out of 423, 43 out of 423, 19 out of 423. And that's the individual percentage. How much does it contribute to the total problems that we have? So each and every problem, how much does it contribute to the total in percentages? That's what we have. Then we look at cumulative percentage, which is this alone is contributing 64.8%, 7%, 64.78 for the first one, plus 13.95 for the second one. Total of these two is 78.7. These two plus this third one, which is 88.89. So top three problems will count for 88.8% problem. Top four problems is contributing 93.38 and so on and so forth till 100%. That's the cumulative percentage. All I need to do is select this, select the count, select the cumulative percentage. I go to insert statistic chart, and that's where my Pareto chart looks like. Let me just scroll it here a little bit, drag it here, some bit of beautification, whatever it is, and get the plus sign. That's data labels. That tells me this is 274 complaints, and that's the same chart that I see here in Minitab. What it tells me, 274 complaints, 59 complaints, descending order. That's what you see, a descending order of the complaints. What we is what we see a count of the complaints here. It gives me the individual percentages, which we have plotted here, individual percentages based on which the bar graph has, this is the individual numbers we're looking at. The cumulative percentages are at the bottom, same ones which we calculated here. And the line that you see on the top is nothing other than this cumulative frequency line, which tells you that's the cumulative frequency line, 200%. Now it tells me that if I go and solve this problem, or if I solve this problem, effort will be more like same, but the benefit will be huge difference. This is going to solve 0.9% of my total problem. This is alone going to solve 64.8%. Don't just solve any problem, solve where it matters the most. So it's 80-20 principle says if you try to fix the top, like it's not have to be very, very stringent about 80%. If I solve these two problems, I will be done with 78.7% of my total problem. Well, it just says prioritize before you pick up a project. Find out what is more concerning and pick up and decide, well, which one is more critical to you. But these are top two critical issues. Just focus on them. Do not waste your time looking into this. These are the top ones. If you solve this, your 78.7% problems will be done. It's more about prioritization model. So you help you to find out where is the problem sitting in your process, where is the maximum problem where you got to focus on. That's what you'd work on Pareto chart. So it's a prioritization model which helps to find out the most frequently occurring problems. That's how you prioritize that. Scatter plot is used for graphically plotting a relation between two numerical variables. We don't need to be very, very adamant about 80%. No, we don't need to be very adamant. It's more about top. See, it's about if it's even 70%, 80, 70%, it's more about focus on where the maximum area lies. You don't have to go 100% be very, very rigid about 80%. No, the top ones where if you see, no, if I'm looking at it, if I'm looking at the chart, all I know is I'm looking at this chart, it tells me that these two problems will alone contribute about 78.7. This has lower contribution. Should I want to include this again, it'll be like 88%. So it's still not going to fit in exactly at 80%. So it's just more about prioritization. It just tells you that if you solve this problem or you solve this problem, effort will be more like same, but the benefits will be huge. So just try and focus on the major contributing cause, and that's what it's all about. It's a prioritization tool by the means of count-based selection of project. It need not be 100% always 80% exact. No, it's just about having an understanding where the major chunk line and just prioritization based on that. Scatter plot, how do you do it? Well, it's like I want to draw a relationship between hours of study versus exam scores. Well, speed of the car versus accidents. Would like to understand advertisement costs versus revenue numbers, some sort of relationship, and that's what you plot with scatter plot. Let's have a quick look at scatter plot. Okay, let's have a look at this. Okay, that's temperature and sales. I would like some sort of confectionery industry into ice cream and all this. They might be plotting day-wise temperature and day-wise sales, historical. That will help me plot this scatter plot and understand what kind of relationship is there in the scatter plot. So I want to understand the relationship of temperature versus sales. So temperature versus sales relationship. That tells me a positive relationship. Why? Because if I see when my temperature is low, my sales is low. My temperature slightly increase, my sales also increase. At a higher value of temperature, my sales is increasing. At a higher value of temperature, my sales, I see the direction of this line, the dot is represented by the line that's going up. That's a positive relationship. When this x value, if it increases, it gives me change with my y value. And what it also helps me to get into a prediction model. If I take my cursor, I get to see this equation. It tells me if I know the value of temperature, I can predict my sales. That's what it tells me. So there's an equation which has been created, which is more from the statistical. This is graphical relationship. The statistical relationship with regression model. So that's what tells me if you know the value of temperature, what's the temperature, you can predict what will be the sales. And similarly, you may have a positive relationship, you can have a negative relationship. All those relationships can be seen when you plot these charts. Let me see if I have one. That's a negative relationship. I could plot this one again. This is mileage of the car versus age of the car. That will be a negative relationship. So I could give you the mileage of a car at a certain age of a car. If I get to know how old is your car, I could give you mileage, how much car would be giving you mileage. That's negative relationship going down. When the car age was less, it was new, the mileage was high. Car age increased, mileage dropped. Car age increased, mileage dropped. So at a higher value of X, value of Y drops. That's a negative relationship. So you could get into any kind of relationship when you're trying to analyze the data. So that's more like, so this is the graphical analysis. Statistical analysis is more done with a correlation or regression test. So it's statistical tests used along with scatter plot is correlation test or regression test, what we study in the analyze part. Fishbone diagram. This is a very interesting one. Like, so basically this 7 quality control rules were compiled by somebody by the name of Ishikawa. This Ishikawa compiled this list. This gentleman, his own creation was only one, fishbone diagram. So fishbone diagram is also known as Ishikawa diagram or cause and effect diagram. As for this gentleman, if you're facing any business problem in any industry, the sources, the causes, the potential causes of that problem will come from 6M. 6M's are responsible: man, machine, method, material, measurement, and mother nature. So if these are the 6 sources of your problem, so you have to sit down, brainstorm as a team and figure out like what is causing the problem. You've got to figure out the potential reasons to what may be causing the problem, and that's what you get with 6M. Let's have a quick look at 6M out here, so that how does a fishbone. So when we plotted this fishbone diagram, I mean, this had a fishbone diagram in this one. Okay, let's have that was a fishbone diagram here. I guess we'll see one. Yep, that's the fishbone diagram. That's how it looks like. So basically, it's plotting your potential causes, and it's used for root cause analysis. Yes, absolutely, yes. So let me quickly say if I have this one out here. Give me one quick second. 1 second, let me move it here. Just move some of the files here and there. That's sort. Okay, now I should have this one fishbone diagram. Okay, let's pick this up. So that's the fishbone diagram data. I could pick up this data. So there is an Excel template. People who do not have access to Minitab use this template for making a fishbone diagram. That's how it will look like in a Excel template. That's the template in which you plot on a fishbone diagram. It looks like a problem is the head of the fish. That's the business problem you try to solve. And these are the 6 M's that we have to use it. So we'll have a brainstorming session with a team. The team will discuss about potential causes we feel it might be happening. So that's how you do a root cause analysis. In Minitab, well, it's a lot more easier to do it in Minitab. So I've copied some of the data. Let me plot this on Minitab and show you how it's done. So quality tools, you got your fishbone diagram out here, quality tools, cause and effect diagram. Well, personnel is man, and environment is mother nature. It doesn't matter, or technically the same thing, but I try to keep it like original standard 6M rather than changing them. So it is, what we do is man is with man, machine is with machine, material is material, method is method, and measurement is the measurement part, and mother nature is mother nature. That's the causes, potential causes that we brainstormed as a team. So what you do here is you write down the business problem. So I'm facing challenges with quality. So quality issues, and say the team has brainstormed. So this is the problem for which we did a brainstorming. So we just click OK. Fishbone diagram is ready. You can change anything with Minitab. It's completely editable. You don't like the color, change the font, whatever you want. It's completely editable. You can do whatever you want with this one. It doesn't matter. You change anything. It works fine. And just everything is editable. You can take it wherever you want. You can compile things and create your own templates. You can create everything in this Minitab. So you can create your own templates, own versions of, you can do anything what you want to with Minitab. That's the finished output. It's amazing software. And that's what management wants. It prepares lots of reports on your own, just a quick glimpse, and everything can be taken, transported anywhere, email, photo, any kind of, wherever we want to do it. It's absolutely a great software. Coming to control charts, that's where the most important part comes into picture, because control charts is what we discuss is the hard control phase. We improve something, you sustain improvement through control charts. So these are called SPC charts, or statistical process control charts. These were developed by Dr. Walter Sheward in 1920s, and that's where it were successfully used in every part of the world. Every possible industry was using it. Well, Six Sigma people came and copied it and made a control phase. They did nothing. Just copy and paste of control charts was done. It was already tried, tested, and used by everyone globally. So they were biggest copycats who introduced Six Sigma. We'll talk briefly about them because that's what will be the next thing about history. But practically, this is what control charts are for. So every project has a control chart that get your process into statistical control, so it doesn't fall back, doesn't crack anyway, and pretty much it helps your process to remain in a statistical control. These are control charts. So you get to know without any fail You'll never be surprised about your process behaving awkwardly. Even if your process is changing for good, you'll know it. Even if the process is changing for bad, you'll know it. Before the change happens, if you're looking at control charts, you will never get surprised. If the change is for good, then you will make it good. You'll let the process behave in the same way, or you'll promote the change. If the change is bad, then you'll fix the problem before it becomes a problem. So it gives immense control in the hand of the person who is making the process control charts and auditing it. You will be able to understand what's happening in my process if effortlessly. You will be able to figure out the process will show indications that it is not working right, something is wrong, investigate. It will give you these alert signs. It will give you those alert signs, the red dots and all those process metrics it will give you the various symbols. It helps you to understand where the process is going wrong. And there's certain things, and these are ahead of time before the problem becomes a problem. You'll know it if you're looking at control charts. So that's what you do in using, and these are simple ones. When you talk about these 7 quality tools, these are simple tools, because along with these tools, you use the advanced statistical tools, which are the statistical tests which we perform. These are simple ones when we talk about 7 quality control tools. Coming to this section, we sort of end this part of it. We have a couple of more topics to talk about, but briefly would like to check, is it okay with everyone, these 7 QC tools? Basic understanding. Perfect. Then let's get into very quick brief introduction about this section also, because from interviews perspective, when you face a job interview, people will ask you, we don't want to become an expert of history, but yes, brief and idea has to be there. We should understand, yes, basic understanding should be there. So all in all, where did it start? We already know Toyota introduced this, but the word lean came from Toyota. They were not the first ones to be doing lean. Like practically, it started with Henry Ford. Like Henry Ford was the CEO of Ford Motors. Ford Motors is where it actually got started. The implementation of lean. The word lean was not known, but they did which was lean. The old version of manufacturing of automobiles globally, any other manufacturing used to happen through crafts manufacturing. Crafts manufacturing was the old version. And let's understand how it's done. Craft manufacturing, just for understanding's sake. The old version, the cars were manufactured at one place. So this is one car, it will be locked at one place. This is fixed. There's another car which is again at different place, and this is fixed, immovable. And the third car, say, so these are cars getting manufactured and locked at one place. If I'm fitting in bulb in a car, I'll move with all the bulbs to this car, fit in the bulb, drag the remaining bulbs to the next car, fit in the bulb, drag the remaining bulbs to the next car and fit in the bulb. Somebody who's fitting in, say, tires or seats in a car will move with all the tires and seats to this car, drag it. It was very, very slow process. And that's what was called craft manufacturing. Well, cars were stationary and people used to move from one car to another. It was a very slow process. That was the problem, very slow process. The production capacity reported numbers is 32 to 35 cars per month, which was the production capacity, and lots of damage was done to the spare parts because of the dragging, because one has to drag the material. Spare parts were completely damaged at times. So that was a bad process. In 1908, they changed the method of manufacturing, which was changed to assembly line. Till date, we use assembly line, which is what we call as conveyor belt concept. Conveyor belt concept just changed the method of manufacturing. Cars started moving on a belt. People became stationary. So rather than people moving from one place to another, it was, say, this guy is fitting in the bulbs, so he's got all the bulbs with him. This guy is fitting in tire, he's got all the tires with him. This guy is fitting in the seats, and this guy, and there was a moving belt. So car comes in front of him, he fits in the bulb, job done, moves to the next guy, fits in the tires, moves to the next guy. That speeded up the process. There was no more dragging of material, it was moving fast. And that started concept of mass production. Well, these guys started the concept of mass production. Their production capacity increased 3 to 4 times. No more damage. Well, that speeded up the production globally. Everyone learned this new method of production, and that was successful. So later on, Toyota stepped in. Toyota is known for getting this word lean. Yes, the world got to know the word lean from Toyota. They have this Toyota production system, which they till date use. Toyota production system is the collection of lean tools, how they used lean to improvise their practice. Just a very, very brief background about it. It's important to understand because that's what will link with Six Sigma. So lean was the reason Six Sigma came into existence. So just a quick one. When Japan was continuously engaged in war, so their economy was in a very, very bad shape. They were depleted completely. And post the bombarding, they was in an absolutely bad shape. So the entire country would have filed for bankruptcy. They were in a bad shape. So as a nation, they had only two choices: either crumble under pressure or with whatever given resources you have, create best out of nothing. You have just limited resources, bad infrastructure, less capital, everything was less good. Practically, it's always said necessity is the mother of invention. These guys understood that, yes, I can't beat, I'm talking about referring to Toyota, we can't beat General Motors. They're huge. We can't beat Toyota. We can't beat this Ford Motors. They're huge. They have complete monopoly in the market, and plus they're producing in huge volume, mass production. We can't beat them in that volume. We don't have that kind of infrastructure. We don't have capital. Well, we can beat them with quality. And yes, they crafted the masterpiece, which is Toyota cars, which are meant just for the end customer. Best cars, reliable cars, less costly, more comfortable, less warranty issues. They were great. People loved quality, and people became addictive of quality standards for the first time. And they loved, and this spread like hell. Pretty much everyone wanted to buy a Toyota car, and General Motors lost significant market share. Ford Motors lost significant market share, and investors started pulling in money in Japanese companies. Not only Toyota, every other company in Japan were flourishing because they had unlocked this masterpiece of lean, which world was still struggling to understand why this Japanese qualities are so good. Well, we are not able. The world was struggling around 91% kind of quality. They were going at 99% kind of quality with lean. They were striking that. It was phenomenal, unbelievable. That was bothering somebody else as well. And who was that? Motorola. Motorola was troubled deeply by this lean. Motorola, the owner or the CEO of Motorola was Bob Galvin. They were in a bad situation. Why? Because of lean. New companies in Japan had started, which were manufacturing pagers, which were manufacturing the walkie-talkie, which is used by security guards and police officials, where they were in such a bad situation because investors were pulling out money, and these Japanese companies were producing like these pagers and walkie-talkie at cheaper price. They were great, and unfortunately, it was a bad phase for Motorola. That's when the project was given to the senior scientist in research and development. His name is Bill Smith. Bill Smith, along with, he's known as father of Six Sigma, along with Dr. Michael Harry, spelled as M-I-K-E-L. They were given a task to beat this so-called lean. I don't know what needs to be done, but we have to get a solution. Otherwise, we will go bankrupt. In 1986, they announced it to the world that we have come up with Six Sigma, a new term for everyone. Nobody knows what is Six Sigma. They announced to the world that this is capable of giving you this level of quality percentage, which means there will be only 3.4 defects in 1 million opportunity. World was taken by shock. I mean, Japanese got shock of the life. Is that also possible? Yes. Well, thanks to Bob Galvin, he was a very noble soul. He never tried to keep it a secret, company, proprietary information. They invited industries to come in Motorola facility, see what is the Six Sigma, how do you do Six Sigma project. They taught industries, and big names stepped in. ABB, Asian Brown Boveri, they till date use Six Sigma extensively. Allied Signal, Honeywell, they were big giants, much bigger than Motorola, but in a different sector. They incorporated Six Sigma, and their cost saving, not revenue, cost saving was in billions of dollars. That became talk of the town. People understood that this is an amazing tool. And finally, the biggest game changer stepped in Six Sigma, which was General Electric. General Electric redefined the rules of the game. Well, when we talk about Six Sigma, we talked about this was led by Jack Welch. Jack Welch, who was CEO of General Electric. Even till date, if you want a job in General Electric, in a management role, you have to be Six Sigma certified. You will not get a job in General Electric if you're not Six Sigma certified. Even till date, everyone understands Six Sigma top to bottom, and that's how the way of life in General Electric is Six Sigma. When we talk about these phases, well, General Electric has to do something here as well. This was all about Motorola version. Measure, analyze, improve, control. Before General Electric picked it up, it had 4 phases. General Electric added the define phase was courtesy these people. They added this project management tools to this because Six Sigma was completely statistics. What they said, you cannot solve any problem. Just try and understand you have limited resource, limited capital, limited time. You have to solve the biggest problem. For that, you need project management. So they changed the definition. They were so huge. They used Six Sigma for themselves. They used Six Sigma for their clients, and they became consultants of Six Sigma, saying that you got a problem, hire us as consultant. We'll solve that for you. They made it popular. And what we know today, Six Sigma is courtesy General Electric, not Motorola, because Motorola did create, but could not get the fame and name. It all came from General Electric. Great industry experts are all from General Electric, and globally people have some linkages with General Electric. That's the one company where still date the core principle is about Lean Six Sigma. Having said that, a quick one without like getting too much of details is the belts part. Very important to understand what are these belts, because you're going through a yellow belt. So let's understand briefly what are these belts. Yellow belt. Is there a belt before that? Yes, there is a belt before that as well. White belt, yellow belt. We'll talk about a couple of more belts here. Green belt. We'll talk about black belt. We'll have then master black belt. And that's the journey ends for Six Sigma belts. That's where we end here. But there are 2 more roles we have to understand. One is champion. Another is sponsor. That's all, and that will be end of my part of it, and all your questions related to the recordings and everything, the notes and everything will come into play. I will sort of take a break then. Let's kind of talk about this. White belt, you do not become a part of a project. You don't become a part of a project, a Six Sigma project. What do you do in white belt? Generally, a case study is explained. Like you are going to do a Six Sigma project, you want at least everyone in the organization should be able to understand what is Six Sigma. So they don't come back and ask like what is Six Sigma. So it's awareness training. Basically, you just talk about one industry, similar industry, how people have used Six Sigma, how it is beneficial, just to create an awareness. But do not learn any tools and techniques, nothing. You have no idea about the tools and techniques used in Six Sigma. So it's just an awareness training. Well, yellow belts, yes. You are a part of a Six Sigma project. Why? Because you have a fair bit of understanding what is a DMAIC, basically overview of DMAIC, and 7 quality control tools. You will closely work with the project managers. So you will closely work with the project managers, which is the green belt or black belt, for their projects, and you will be a critical element because you will be completely helping them to execute the project. It's very important. But yes, you don't lead a project as a project manager. You work with them as a team member. So yellow belts are team members, very important resources of every project, team members, which gradually become a green belt or black belt eventually. But somebody who's a green belt or a black belt, let's see what's the difference between them. Project management skills. Technically both have same. There is no difference in the project management skills. Why? Because both have to lead a complete project from define till control. There cannot be a gap there. They both same. Where is the difference? Statistical knowledge. That's where the big gap comes into picture. This is, I would say, low to medium, and this is extensive. Extensive. Why? Because there will be a lot of things which will be covered in the black belt. Plus, there is something which you call as design of experiments, which is where we statistically get into designing and development of a product or service. It's all done statistically. Even your COVID vaccines have gone through design of experiment. It's extensive. Like right now, we'll not be getting into technical stuff, but let me give you high-level information. In green belt, we deal with normal data only. Here, we deal with normal data, non-normal data, any kind of data basically gets covered. Non-normal data, categorical data, which is binary data, ordinal data, nominal data, count, percentage, and they're different. So bottom line is black belt, there's nothing which is left over after that. You cover everything. Green belt is the first stage, but this is where you completely a master of that. Now, what is the other difference between green belt and black belt? Technically, the duration of real world project. When you're doing a real life project, how long is technically, not every project has to be there, but technically green belt takes about 4 to 6 months and black belt takes 9 to 12 months. But it may vary. This is overall average, but some project can take about 3 years, 4 years also. But typically most projects will take this much. Other than that, cost saving. Now, cost saving is one criteria which cannot be defined as a rule, because small company will have a different criteria to say, well, this is green belt and this is black belt. Who will decide? The stakeholders of the organization will decide. Technically for General Electric, this is only for General Electric. If it's less than $10 million, they call it as a green belt project. If it's more than $10 million, then they say it's a black belt. It's only for General Electric. Well, you decide your company, how would you call this is a green belt and black belt? The stakeholders will decide it, what is a green belt and black belt. Technically, role. Green belts work within their department. Well, why is that? We have been talking about Six Sigma has no boundaries. Then why are we saying they work within the department? Can green belt work in other departments, other industries? Absolutely yes. But culture globally is that green belts are only working within the department. If you are from operations, you will be working within operation, doing a Six Sigma project of operation. If you're from quality, then you'll be doing only projects in the quality department. If you're from finance, marketing, then you will be doing a project within that. Is that a rule? No, it's the culture. Why? Understand the reason also. If you're working as consultant, then there's no limit. But if you're working in an organization, the work ratio is 70-30. So 30% on project. Why? Because the department hired you. For example, I'm an HR person. I was hired for doing HR job. So I will still be doing my 70% of HR job because I'm being paid salary by the HR department. So HR department wants to give me 30% time to solve HR problems because I'm being paid by the department. So that's why it's not a rule, but the department who's paying you salary wants to still continue with the work of HR work and still wants you to solve some problems with the 30% on project. Black belts, well, no limit. Cross-functional, they work with every department. They are 100% project managers, 100% free to explore any area don't have a limit. Comes to master black belt. Who is the master black belt? An experienced black belt will be a master black belt. Well, these guys have it like a team size of 9 to 12 like green belts or black belts. So they will monitor like about 9 to 12 projects at a time. So as a master black belt, I don't have a team of mine when I'm working as a consultant. But if I would have been working in an organization, I would have a team which will be working with me. So as a team, like when I'm working in an organization, technically I'm not doing any project as a master black belt. Green belt knows green belt job, black belt knows black belt job. This guy is more of a mentor or coach or guide who will help green belts and black belts to understand if they get stuck, they can reach out to this person. This guy is more of a mediator between management and Six Sigma department. Basically, that's what we have. This guy will not be doing a project unless you're a consultant like me. Then I'm on my own. I'm working with an organization. Then pretty much I'm working as a consultant. That's how it works. But that's what is master black belt. Last but not the least, couple of designations. Sponsor will start just funds the project. You don't know. Ideally, we don't deal with the sponsors because sponsors will not be interacting with us. Who will be interacting with us? The champion. Now, who is the champion? Champion is the owner of the project. Champion is the owner of the project. Who is the owner? Technically, the VP or head of department is the owner of the project. So this head of department would have tried to solve the problem with the stakeholders, with the subject matter experts. The problem would have not been sort of settled. That's when this owner of the department speaks with the Six Sigma team that we've got a problem. We try to solve it. It's not getting solved. I need your help. So champion and Six Sigma team will sort of work together to put together a project. So champion owner of the project is the champion itself. You have been hired as a resource. You've been contracted as a resource to solve a business problem. And that's when we go into the last part here, which is this person is responsible for approval, denial, or review of the project. Success or failure of the project is champion's responsibility, not yours. You're just a facilitator. You're just helping the champion complete the project. But the owner of the project and success and failure is all responsibility of the champion. Yes, you are getting the project done for this person. So yes, champion will be responsible for removing the roadblocks in the project. Well, it's not your problem in the project. Somebody giving you a tough time, do not wait. Involve champion, because if somebody is messing around with you, not giving you information, giving a run around, do not wait. Involve champion by the virtue of the authority and position champion has in the organization, which champion will help you remove the roadblock. Do not wait and sit. Last but not the least, last line here, champion may be himself or herself a white belt only, or a yellow belt only, or a green belt only, or a black belt only, or himself or herself a master black belt, or even none. You don't need to be a Six Sigma professional to become a champion. Well, that's an extra skill, but your vice president may not be a Six Sigma professional. That's a management. This is we Six Sigma people. We Six Sigma people call this management designation as champion. This guy is called champion. We call it champion. So this champion may not be a Six Sigma professional. It generally, I have been doing a lot of such trainings, which are specialized training, customized training for CEOs globally. Fortune 500 companies have delivered exactly customized training for them. One or two people are sitting in a training, and those are extensive, like long duration trainings. And we have those trainings. Globally, I've seen the demand of Six Sigma at higher management, top management. I've been doing such trainings extensively across the globe. And I have seen in like nowadays, the champions are Six Sigma trained. Like when we used to do it like about 10 years ago, things were different. You generally interacted with people who are not, who wanted to do Six Sigma, but had no idea. Nowadays, we find champions are well versed with Six Sigma. So it's a need of the hour. If you want to be in management and you want to get good position, definitely you need to have strong concepts of Six Sigma. People love people who understand the language of data and how to manage projects. You will be always loved as Six Sigma professional if you know how to understand, like deal with the challenges. Bottom line, but that brings us to the end of my bit of role in this one. But I guess before I take a leave and probably hand over this this session to Michelle, I would like to thank each and every one of you for your valuable time. And I'm sure we have questions, which Michelle will come and address those questions about notes and everything else. So, but yes, it definitely is a pleasure to be able to interact with all you professionals across the globe. You have been a great audience, and I would love to have more interactions like this. So thanks to IMC for giving me a platform to interact with such professionals globally. Thanks, everyone. Thanks for your valuable time. And I would like to kind of hand over the session to Michelle.
Yes, sir. Okay. Thank you so much, Mr. Shashi, for your very valuable training today. That was very informative, sir, and fruitful discussion as well. Just a minute, everyone. I'll be sharing my screen. Just want to confirm everyone if you still have more questions regarding Lean Six Sigma. Hello, am I audible?
Yes, Michelle, you are. I guess we're all good.
Yes, we just want
To know because right now I'm just having some technical issue from my side. So while you're here, maybe there are some questions regarding Lean Six Sigma. So at least Mr. Shashi is here. He can respond to your queries.
Yes, yes, please. In case you have any questions on the topic and the subject, but yes, other than that, if your questions rest, Michelle is going to take it over and she will be responding to all those questions. But yes, if there's anything which is there shared by you, it's not been answered, it will be definitely taken over. Thank you, Michelle.
You're welcome, sir. So again, thank you so much, sir. That was very valuable training for today. And also, I would like to thank everyone. Good job for making it till the end of the session. We do hope that you all have enjoyed it. Moving forward, as a reward for tuning in and with regards to the special announcement, which I have mentioned earlier, many of you might be thinking of getting this participation certificate. This is a proof of your attendance for this training, right? So instead of paying the regular price of $50 for a minimal amount of $20, you will get the participation certificate. This is how it looks like. It is provided with a certification number here, the session date, the total duration of hours of the training, plus the logos of our accreditation bodies, which is the CPD and CSST or Council of Six Sigma Certification USA, plus the signatories. Okay. And however, it would be much. So we have another package for that, which includes e-learning access, examination, the achievement certificates, plus free participation certificate. And the trainer's note as well will be there. And the trainer's notes. And also, you will have a free access of today's video recording. So the recording is downloadable, so you can save it in your desktop or mobile. So you can watch it even you are offline whenever you want a recap or review this training session. Regular price is $200 US. And now we're offering it for only $60 US. So what are the benefits of getting certified? First, career advancement. Having that certification, it will provide you an endorsement to employers that you have an explicit skill set. Competition for employment can be severe as of now. So by having proof that you have awareness and you can apply Lean Six Sigma, it can set you apart from the crowd. Secondly, certified Lean Six Sigma professionals get good chance of growing to senior managerial positions. Third, certified professionals are among the highest paid professionals globally. And this is also applicable to all types of industries, as Mr. Shashi already mentioned a while ago. So what is the e-learning portal? Once you avail the package of $60 US, you will get your own credentials. We will be providing you a username and password, which you can also reset if you want to change it. Plus the ebooks, PDF presentation, and plus the pre-recorded video and sample questionnaires and case study materials, which are all accessible for lifetime. So this is how it looks like. This our recording will be here, the PPTs and other class materials, plus the sample paper. I'm sorry, everyone. I'm just facing some internet issue. Just kindly give me some 2 minutes more. I'm so sorry for this issue. I'm just gonna rejoin the meeting now so I can reshare the slide. Please tune in, everyone. I'm so sorry for this technical issue that we are facing right now. It's because of the intermittent connection. Just one more minute. I will reshare the slide. Just want to confirm if the screen is visible from your side. Hello?
Yes.
Okay, thank you so much. And again, I'm so sorry for this technical issue. Okay, moving forward. So this will be the e-learning portal that you will get. And also, once you get the $60 package, the examination will be here also. Okay, so about the assessment, this is flexible within 3 to 4 months upon enrollment. This is an open book online assessment, and you will have 20 multiple choice questions, 30 minutes duration also, and you have 50% passing percentage. So out of 20, you'll just need to have 10 correct answers. Plus, you will have free 3 attempts of final assessment. So don't you worry if you fail for the first attempt, you still have 2 more remaining attempts to take. And the dual certification. So we are calling it dual certification because you will get 2 certificates, or what we call, again, dual certification. One from IMC and one from CPD UK London. And both are internationally recognized with lifetime validity. This is the CPD certification and the IMC Achievement Certificate. IMC Achievement Certificate comes with logos of our accreditation bodies, signatories of our company directors, plus a unique certification number will be there, which can be used by employers, clients, and other stakeholders to validate the authenticity of their Lean Six Sigma certifications, which you have received. Here is the CPD certification. As we have mentioned earlier, that IMC is a proud CPD member of this organization. Or the continuing professional development. This is an avenue for professionalizing learning, which is based in United Kingdom, London. It comes with unique certificate number as well, plus the number of CPD hours and points. So both of these certifications are internationally recognized and with lifetime validity, meaning it doesn't expire renewal fees. So how to avail? You just need to pay it through online payment via Stripe Gateway. You will be required to fill out your name, email address, phone number, and card details. And once you're finished, just click the pay button. So, okay, again, please check the chat box here for the payment link. I guess it's already shared by one of our service team. And I will reshare it again.
Hi, Michelle.
Yes. Yes, ma'am.
Michelle, my name is Sadak. How can I pay in Indian rupee the $20 fee?
You can use the same, ma'am. You can use the same link.
So it will directly get paid, or will it get converted and then
Yes,
there will be conversion rates
it
applied?
will get directly paid, ma'am. Even if it's $20 USD anywhere you are located, this is okay. No problem with that. And if there are any issues regarding the payment, just kindly message or drop an email to michelle@imclearning.com so I can guide you how to pay for that. Okay,
sure. Thank you.
Okay, great. Moving forward. So upon payment, once you're done with your payment, Please make sure to send a screenshot to your respective counselor's email or WhatsApp to expedite the process and receive the following. You'll receive an email from the service team along with a payment confirmation, participation certificate form, and please take note that the processing will take 2 to 3 days upon receipt of the completed form. So once you receive that email, make sure to fill out the required details and send it back to us so we can start the process of your certification. Plus, the document for the examination guidelines will be there also. It will be attached on that email, plus your login credentials or your username and password, plus the link where you can access your LMS portal, and the recording or class notes via Google Drive link will be provided as well. And please take note that the recordings will be available and uploaded within 2 days. So avail now and don't miss this exciting one-day offer. And I want you to know how to connect to your counselors. So just kindly check your email invitation and reach them via email or WhatsApp. Some of you might receive an email from Soryanj, Frixie, Michelle, and Somia. So just kindly check out that email. On the bottom part, you will see their email here. Plus, this is the link where you can message them directly to their WhatsApp or click this icon. Plus, for those who wants to upgrade their belts, okay? To know how to upgrade, again, just make sure to drop an email or WhatsApp message to your respective counselors, because we have from 50% to 75% discounted offer. It varies, depends on the country where you're located. So for those who want to upgrade for Lean Six Sigma Green Belt, Black Belt, Master Black Belt, or Lean Six Sigma Green Black Belt combo, plus with exciting freebies. Okay, and for your information, if you want to upgrade to Green or Black Belt or Master Black Belt or combo, you will get the Yellow Belt package for free.
Michelle, do I
So
still
please
have
take
to pass
note.
the test?
Yes, sir.
Do I still have to pass the test for yellow belt if I am registered for green and black combo? Is it going
Yes,
step
sir.
by step?
Yes,
I mean,
sir. Yes, sir. Yes, sir. You need to pass the Yellow Belt.
Okay.
Okay. So please take note that our 50% to 75% discounted offer is only valid within 3 days. Okay. So please drop an email or WhatsApp, drop a message through WhatsApp to your respective counselors so they can explain to you everything you need to know about the course, pricing and discounts, payment terms for installments, and so again, this is valid until today only, so don't miss the chance to avail this limited offer and get certified. Please do check our website at www.imcinstitute.ae. For more info, again, this is the link, www.imcinstitute.ae.